1, 1, and so on. Okay, so this is a constant sequence, right? See, all the terms of the sequence are same. So this is a constant sequence. And similarly, I can take some other sequence. Let's say 1, 4, 9, 16, and so on. So yeah, so these are some types of sequence. So we are interested. So basically, what we want to find, we basically interested in something called limit of sequence. So we want to know how the sequence behaves when actually n goes towards infinity. Okay, so we want to know how the sequence behaves when n goes towards infinity. So that is called the limit of the sequence. So limit of the sequence is basically what it's, so when you have a sequence n, okay, so suppose you have a sequence an, so this is how we write for a sequence an. So we say that the limit of this sequence is a, right? We say that the limit of the sequence is a. So when we can say that the limit of the sequence an is a, if an will go closer and closer to a if you increase the value of n, right? So if you increase the value of n, that means if you take a1, a2, a3, a4, as the sequence goes on. So if you increase the value of n, okay, so this if you increase the value of n, this all the terms of this sequence will come closer and closer to a. Then only you can say that the limit of the sequence is a, right? So then only you can say that the limit of the sequence is a. So when you don't have any such a, okay, so for example, if you see when you don't have any such a, then you say that sequence as a divergent sequence. Okay, that is not convergent sequence. So when we have a limit, so when for a sequence, when we have a limit a, that means all the terms of the sequence come closer and closer to a. In that case, we say that that is a convergent sequence. And when we don't have any such a, in that case, we say that the sequence is a divergent sequence. For example, if you see this sequence, for example, if you see the second sequence, as so if I increase my, so this is my a1, this is my a2, this is my a3, this is my a4. As you can see, if I increase the value of n, this thing actually is going towards infinity, right? If I increase the value of n, this sequence is the term of the sequence is getting larger and larger. So basically this thing is going towards infinity. That means it's not going towards any particular number a, right? It's not going towards any particular number a, right? So this term of the sequence is going towards infinity. So that means this is a divergent sequence. Whereas if you see the first sequence, okay, 1, 1, 1, 1, 1, as you can see, all the terms of the sequence are same. So if you increase the value of n, this basically everything is going basically towards 1. So precisely everything is 1. Okay, so that means so I can say that for this sequence, this if I increase the value of n, then n is basically going towards 1, right? N is basically going towards 1. That means the limit of the sequence is 1, right? So that means this is a convergent sequence, and the limit of the sequence, the above one, is basically 1. Is it clear?
Yes, sir.
Yeah. Okay, so yeah, so let me solve few questions. Okay, so
Sir, 1 second, sir.
yes.
Sir, when you started that limit 1111, you told it is not going anywhere, it is going to infinity.
Below one, yeah, below one.
Oh, below 1. Okay. 11111 is a convergence
Yeah,
sequence.
it's basically 1, right? It's all the terms basically it's 1. So you can say that the sequence is going towards 1. Yeah.
Okay, thank you.
Yeah. Okay, so let me take this sequence. So as you can see, this is so so the first term of the sequence, okay, so this is, yeah. So, so this is my sequence, right? So that nth term of my sequence an, so nth term, so this is basically the nth term. Okay. So this is the nth term of the sequence, right? An is equal to, so I can, if you want you can certainly, you can write all the terms like, so if you want the first term, let's, so a for a1, what you need to do, you just need to substitute n equal to 1 this expression. Okay, so for, so if you do that, then probably you will get 5 plus 3 8 plus 2, this is 10. Okay, so this is 10, and this is 4 plus 2 6 plus 1, this is 7. So this is the first term of the sequence, and similarly, if you want, you can also write down the second term of the sequence. Yeah. So similarly, you can see, you can, like, by using this algebraic expression, you can actually write down all the terms of the sequence. Okay. Uh, okay, but the thing is, we want to know what is the limit of this sequence. Okay, so so yeah, so the thing is, if you write down few terms, okay, so which is not that difficult. If you write some maybe 4 or 5 terms of the sequence, actually you can see some pattern from that, from those numbers, that what can be a limit of the sequence. Okay, so okay, let me do it more rigorously. So this is my sequence. Okay, so the nth term of the sequence is nothing but 3n square plus 5n plus 2 4n square plus 2n plus 1. So what okay, so can one of you tell me what I need to do to find the limit of this sequence?
Make n, bring out n square out.
Correct, absolutely correct. So we just need to uh, so the idea is, we need to get rid of this n square. Okay, so in the sense, like, so that like we need to bring this n square to the denominator. Okay,
Let's say taking n square common both the, I mean,
yeah,
on, like,
correct,
denominator,
yes.
numerator.
Okay, just a minute, let me stop my yeah. Correct. So now what I need to do, I need to take n square common from the denominator as well as from the numerator. So if I do the thing for the numerator, what I will get, n square into.
Sir, we can differentiate also.
Sorry.
We can differentiate also.
But why you want to differentiate this? My question is, why you want to do that? Hello?
Yes, sir.
You're audible, sir.
Yeah, okay, Amit Kumar. So my question is, why you want to differentiate it? Because I don't want to differentiate it, because I don't need anything related to differentiation. I'm just finding the limit of the sequence. Okay, and there are so many problems, like it's yeah. So it's a sort of it's basically from. So if you think this, as I said, this is basically, it's a function from the set of all natural number to R. Okay, so in some sense, there is no point of differentiating this kind of function. Okay, so because n is, in some sense, is a discrete space. Okay, so it's if you have a function from some interval to R, or maybe some R to R, then it's really interesting to see the derivative of the function. But when you have a function from set of all natural number to R, there is some sense, there is no point of differentiating this type of function.
Okay, sir.
Vazi, sir, good morning, sir. Sir, I had one question. Can I ask quickly?
No.
2 minutes.
Which one? This related to this question.
Not a question. Not question, sir. Actually, that yesterday, that group is there where TAs will help us, right? In the evening from 7 to 9. There is a group where TAs will help, sir. Nobody is coming there. Actually. So a lot of students joined yesterday. We were there for 1 hour, but no, there was nobody who joined it from. I mean, as a TA, there was nobody there.
Is there so there was any session for yesterday for TA? I don't know because I can't see anything in the calendar.
Sir, there there are groups.
Okay, that's a
Study rooms are made.
The
And,
link was
created.
shared to us.
Link
via
was
mail.
shared
Your
via WhatsApp.
Your seniors, then you can ask questions. And
okay. So whether my voice is clear, I can't hear your voice at least. Hello.
You're
Sir, his
perfectly
voice is
audible, sir.
different.
Oh yeah, yeah. So okay, so there was so this, I don't have any idea about this. Okay, like that's study room. Okay. As far as I know, there was no session for TA. Okay, I can't see any link.
link is
Please.
Thank you.
Okay,
So can I
so
make a comment about the example you're looking at? Because someone asked the question, can it be differentiated?
yeah.
Basically, you can't differentiate this because they are discrete points when you input n. It's a discontinuous function, so therefore you can't really differentiate it.
No, you can actually. So as I said, like so the thing is okay. So okay. So I just so I wanted to avoid that. So actually, as I said, like this is a discrete space, as you have said. Okay. So basically, so in discrete space, all the functions are actually continuous and differentiable. Okay, in some sense. Okay. So when you are taking in some sense when you are taking functions from set of all natural number or discrete set. Okay, so there is something called topology. If you go towards that, then only you can understand like why this makes sense even for a discrete space also.
Oh, okay, thank you.
Yeah. So okay, so as you can see, I can rewrite this sequence like this, and so now I have two things over here. So this is basically my numerator, and the below one is my denominator. So what I want to do, I want to find the limit of the sequence, and as you can see, if n goes towards infinity, right? If n goes towards infinity, then as you can see, 5 by n will go towards
0.
0, right? And similarly, 2 by n square will also go towards 0, right? So as a result, the whole thing that is there in the numerator, the whole thing will go towards 3, right? And similarly, you can check that whatever I have in the denominator, so this will go towards 0 and this will go towards 0. As a result, the whole thing will go towards 4, right? So finally, I can say that the limit of the sequence is 3 by 4. Please mute yourself. Yeah, so Rohini, can you mute yourself? So any doubt from question number 1, like how to find the limit of the sequence? So it's clear, more or less clear, right? The limit of the sequence is 3 by 4, right? Because
Yes,
you just need to divide n square in both denominator as well as in the numerator. And yeah, so this is how you can find the limit of this sequence, which are basically in sort of in sort of some polynomial by polynomial form. Okay. So what about the second one? How you can find the limit of the sequence which is given in this second one? So this
The
is
rationalizing.
Rationalize
multiply,
it.
multiply by root 2n plus 1 minus 2n, both in numerator and denominator,
yeah.
and a plus b
Rationalizing, sir,
into
basically.
a minus b.
Correct. So that is actually the probably the best way to do this question, because if you try to do it directly, then basically you will be in trouble, because you don't know, like, if n, so if you take n towards infinity, okay, so if n goes towards infinity, as you can see, this thing, whatever, this will go towards infinity, okay, and this will also go towards infinity. So basically what will happen then, basically you are in some infinity minus infinity form. Okay, so when you have infinity minus infinity form, you can't conclude anything. Okay, so you can't conclude anything. Okay, that is the problem. Okay, so when you have infinity plus infinity, then certainly you can say that, okay, it certainly is going towards infinity. Okay, that you can do. But when you have infinity minus infinity, then from there you can't conclude anything. So that is the problem with this sequence. Okay, you are basically in infinity minus infinity. Okay.
Excuse me, sir.
Yeah.
Sir, in the previous example, if we keep on differentiating the numerator and the denominator, we'll eventually get to 6 over 8, which is equivalent to 3 over 4. So just assume it to be continuous, then I guess that we could find the limit of the sequence.
But again, like, why you want to do like this? It's more or less, it's much
No,
more
it's
easier.
only we are only assuming that the given function is continuous, although it is not. But we are only assuming.
But I guess my question is, why you want to do like this? Because this question is much more simpler than you can do it much more simpler way than doing like this, right? We are basically differentiating it. You have to differentiate it maybe three times. So basically, what you are doing actually, you are finding out the limit of the sequence at uh, as n towards as n goes towards infinity. That is what you are doing, right? You are
Yes, sir.
basically applying the L-Hospital rule, right?
Yes, sir.
So why you want to do like this? Okay, that is not necessary, right? You can do it much more simpler way. We are making some simpler thing to much more complicated thing.
All right, sir.
Okay, so okay, let me do this one. So as many of you suggested, we need to rationalize this thing. Okay, so this is my sequence. Okay, 2n plus 1 square root minus, right? So what I will do, I'll multiply. So this is basically, I can rewrite this as by 1. So I'll multiply this with the denominator, and as well as in the numerator with this thing, 2n. So basically, in overall, I'm multiplying 1. Okay, so it's not going to affect anything. Okay, because this whole thing is basically 1. So now if I rewrite this, then what I will get, it's basically 2n. So if basically what I'm doing, I'm multiplying this one with this one.
A minus B, A plus B.
Correct. Yeah. So so this I can rewrite as like this, right? So from now it's clear, right? What will be the limit of the sequence?
Zero.
Zero.
Yeah.
Sir, zero.
Yeah. So as you can see, like now we are in actually in a better situation. As you can see, when so from here, as I said, you are in basically infinity minus infinity form. So you can't conclude anything. So if you if as n goes to infinity, as you can see, this thing, this is basically it will go towards infinity, as well as this will go towards infinity. So now, but now you are in infinity plus infinity situation. So then the thing in the denominator, that will go towards infinity. So as a result, the reciprocal, okay, that is 1 by that thing, will go towards 0. Okay. So this will go towards 0. So the limit of this sequence is 0. Okay, clear? Any doubt from question number 2?
Yes,
Okay,
no.
fine. Okay, so what about so suppose you know something about a sequence. Suppose you have a sequence an, and you know that which is basically defined by this. So this is my an which is n by 1 power n. Okay, and you know that, suppose you know that the limit of the sequence is 1. Okay, so that you know, which is given, limit n tends to infinity n,
0.
which is basically 1, right? Okay, so this is given. So using this thing, using this information, you need to find out the correct option. Like if this is true, what can be the possible limit of the sequence which are given in these options? Okay, so can you tell me what about the option 1? Because option 1 is basically what it's, so my sequence is what in option 1, my sequence, let's say bn. What is bn? Bn is basically ln n by n. Okay, n power 1 by n. This is the sequence. That means the first term of the sequence will be ln1. Okay, t2 is ln 2 power 1 by 2, which basically you can write it as ln 2 by 2. Okay, so these are the terms of the sequence. So you need to find the limit of the sequence. Okay, so this is your sequence. You need to find the limit of the sequence. So how we can do it?
As per the rules, sir, ln, that is log retains the limit.
Correct,
So,
correct.
then an is equal to a. I mean, if an is equal tends to a, then ln of a tends to a.
Correct, correct. So the thing is,
First
okay,
option is
so
wrong.
okay, I don't think so. Okay, let me check. I am not sure. So the thing is, you can actually, so the good thing
So we
about
can
this,
take the limit inside ln, right?
yes, that is what I was saying. So the good thing about this ln function is you can actually interchange the value of the function and the limit. Okay, so that is the good thing about the log function. Okay, so so this I can write limit n tends to infinity 1 by n. So what I can do now, I can take this limit inside. Okay, so this I can write it as ln limit n tends to infinity. Okay, so now so now one thing I know, that this limit of this sequence n power 1 by n is given, it's 1. Okay, so this is precisely ln of 1, and you know the value of ln of 1 is basically 0, right?
Okay, correct, sir.
Yeah, so that's why the first option is correct. Okay,
Sir, can you just
Sir,
talk about why we are able to take the limit inside?
that is basically because one thing, that the log function is continuous. Okay, when a function is continuous, actually you can do this thing. Okay, you can take this limit inside.
sir, can we prove that limit of n power 1 by n is 1? How do we approach?
Okay, so that is slightly tricky. Okay, you have to do lot of calculation. Okay, so if you want to do it much more rigorously, then you have to do lot of computation. Okay, that requires some
I'm just
binomial.
curious whether, yeah,
Sorry.
I'm just curious whether we will be asked this kind
No,
of
no, 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 no.
sequences.
So that is why, as you can see, it's in the question
Sir,
itself.
we
Just
can
a minute.
use that option one for proving that, like.
Okay, so please let me complete my statement. So that's why you can see, like, we have already mentioned it here, like the limit of the
Yes,
sequence is 1. Okay, because it's slightly difficult to find the limit of, like, yeah, so find the limit of the sequence. If you want to prove it, then you have to do a lot of calculation. Okay, you, as far as I remember, you have to do some binomial expansion, and then you need to show these things.
Okay.
Sir, do we need to remember standard limits? Like sin x by x is equal to 1?
I'm not talking about limit of functions now. I'm just talking about the limit of sequence. Okay. So yeah, I'll come to that. Any doubt from this option 1?
No, sir.
No, sir. Next.
Okay. Yeah. So similarly, you can do the same thing with option number 2 as well, because again you have log function, so you can interchange the limit and the value of the function. So what you can do, you can basically you can limit, can write this. So this you can rewrite as ln, sorry, yeah, correct, ln limit n tends to infinity 1 plus. So can you tell me what will be the value of this thing? Limit n tends to infinity 1 plus n power 1 by n.
2, sir.
Sir.
LN2.
Yeah, so the final answer will be ln
0.
ln2. Okay, certainly this is not 0. Yeah, this is not 0, right? ln1 is 0, ln2 is not 0. So yeah, so you can.
Can you, sorry sir, can you tell us how we got 2?
So basically, can you see from where we are getting to? I can tell you why we are getting to, but can you tell me from where we are getting this to? What actually we are doing so that we are getting to? Hello?
Limit n to infinity 1 plus n raised to the power 1 by n.
Yeah, this is basically, I'm claiming that this is 2, right?
Yes.
So basically what I can do, so this limit n tends to infinity, so I'm trying to find this thing, right, and this
Yes.
I can do right like this, right?
1 plus, yeah, separately.
So what is this thing? What is this thing?
This is given as, sorry, 1.
1.
Yeah.
And what is this thing? What is the limit of this sequence? 1. So this is basically a constant sequence, right? So this is also 1. So
okay,
basically we are getting 2.
Yeah. Thanks.
Yeah. Okay, so yeah, so for option 2, certainly it's incorrect. So similarly, I can do the same thing for option 3 as well. Okay. Yeah. So you can try option 3. Let me do maybe, because the same thing. It's basically some other form of whatever we have done in option 1 and option 2. Okay. So what about option 4?
Sir, option 3 is correct, right?
Okay, I need to check. Right, then only I can.
Accept
So
it.
this is, as you can see, as n goes to infinity, this will go towards ln2.
0. Oh, yeah,
ln2.
LN2 minus 0.
Yeah. So this will go towards ln2. Yeah, correct. So the whole thing will go towards 1. Yeah, you are correct. What about option 4?
It is also true. Oh.
I guess, yeah. So again, like I just need to
Sir, you have copied it differently from what is given. 4 into n power 3 by n it is.
okay. Yeah. 3 by. Okay. So as you can see, if I take this n tends to infinity, then basically what we have n power 3 by n minus limit n tends to infinity 1. Okay, so one thing I can rewrite this 4 I can take out. So this is limit n tends to infinity n power
1 by n to the power of 3.
3. Okay, and this is limit n tends to infinity 1. So we know that as n tends to infinity, n power 1 by n will go towards 1. That means the whole q will also go towards 1. Okay. So then this is basically 4 minus 1, which is 3. Okay. Clear? Option 4?
Yes, sir.
Yes.
Yeah. Okay, so okay, so I'll come to this maybe sandwich thing. Okay, so before that, let me discuss something else.
This document also you will share, right?
Yeah. Okay, so just let me add something else here. So some other limit thing. So suppose if I take this sequence, let's say like it's more or less clear 1 by n. The limit of the sequence is 0, right? That you
Yes.
know. So if I multiply a constant here, okay, so let's say if I multiply some constant c by n, okay, let's say c by n, what will the c is a constant, okay, it's a big fixed value, c is a fixed value. What will be the limit
Still
of
0.
Still
0.
0.
Still 0, right? Okay, so still 0. Suppose I take sine n by n, what will be the limit of this sequence?
0, sir.
1.
1, sir.
1. Oh, 1.
Any other answer? Someone said 1, someone said 0. Why this is 1? Why this is 1?
We can apply the L'Hospital's rule. Otherwise, also we know that sin x is always a bounded function. Like
Okay, so the problem is okay. So okay, just a minute, just a minute.
Sir, this is 0.
Yeah, this is 0. But the problem is, whatever you are saying, you are correct. This is 0. So the thing is okay. So you are actually mixing two things. Okay, so you are basically mixing two things. So what actually you are computing? Limit
Sin x by x.
X tends to 0, sine x by x. Okay.
This is 1.
So this basically by just remembering this fact, you are saying that this limit of the sequence is 1. Okay, as you can see, when I'm writing sine x by x, I'm taking this x towards 0, right?
Yes, sir.
I'm taking this x towards 0. When I'm trying to find the limit of this sequence, what I'm doing, where I'm taking this n?
N is going
We are
to
taking it to infinity.
Infinity. You can see the difference, right? These are completely two different things.
Yes, sir. And we cannot
Sir,
apply
but still,
L'Hopital.
but still, sin x is a bounded function which always takes values between -1 and 1, right?
Yeah, correct.
So then some constant it will be divided by n will be again 1 by constant by infinite. So will it be 0?
Yeah, that is the correct answer. Right, that is the correct answer. 0 is the correct answer. But like my guess.
But L'Hospital's rule applies for infinite by infinite form or 0 by 0 form also, right?
Yeah, infinity by infinity form also you can apply L'Hospital, 0 by 0 form also you can apply the L'Hospital, but this is not in infinity by infinity form, right?
It is in form of
Okay,
0 by
okay.
infinity.
It's not even
Yes,
form
I
of 0 by infinity. If n goes to infinity, you don't know where the sign n will go. Sign n is basically, if you take this sequence an, sin n, okay, this is a divergent sequence. Okay, this has no limit. Okay, it's, you know that what is the graph of this sine thing? It's a oscillating graph, right? Correct or not?
Yes.
So okay. Yeah.
If nothing is mentioned, we should take for n tends to infinity or n tends to 0.
For that, you should check the definition of the sequence. Okay, if nothing is mentioned, how you can find the limit of the sequence? For that, you need to go and check the definition of the limit of the sequence. So again, as I said, you are actually mixing two, three things. Okay, so it's asking you find out the limit of the sequence, but what, instead of that, what you are trying to do, you are trying to find the limit of the function. Okay, so instead of taking sine n by n, what you are doing, sine x by x, and you are taking limit x tends to 0. Okay, these are completely two different things. Okay, so
So in last mock test, first question, they didn't mention where n is tending to. So for that first question.
mock.
Yes, sir.
No, when they ask about finding limit, we should
Then they ask.
always assume that n will go to infinite, right?
So that is,
Sure.
you need to find the limit of the sequence, right?
That's what even I think she is asking the same.
So
Yes, sir.
If they
First
just ask
question is
limit,
about
we'll put
sequence.
n tends to.
yeah, so when basically, so that is what I am saying, right? You need to find the limit of the sequence. Okay, so when you need to find the limit of the sequence, you have to always, by definition, you have to take n is going towards infinity. Okay, that is what you go and check the definition of the limit of the sequence. When if you, that is what I have in the very beginning I said, right? What do you mean by this limit of the sequence? So if you increase, like if you increase as n increases, okay, if you n, so you need to check where the value of n is going when you are increasing the value of n. Okay, that is what you need to check when you are checking the limit of the sequence.
Okay, sir. Thank you, sir.
Yeah. Okay, so let me tell why this limit of this sequence is 0. Okay, so again, like if you know this sandwich principle, right? So this is basically, it's more or less the same thing as many of you said, right? So you know that sine n, so sine x is basically, it's a bounded function, right? If you draw the graph, then basically it will, right? So more or less it will look like this. So as you can see, the value actually, it's basically in between always. Okay.
-1 and 1.
-1 and 1.
Yeah, so this value is always, is basically, this is 1, this is -1. Okay, so the value is basically, it's always lie in between -1 and 1. Okay, so again, let me tell you, like if you can, okay, that's why I guess I was writing this. So if you take this sequence, an equal to an equal to sine n, okay, this is not a convergent sequence. Okay, because as you can see, this is actually oscillated. Okay, it's not going to some fixed value. Okay, so this sequence, if you take this, the limit of this sequence doesn't exist. Limit of this sequence doesn't exist. Okay, but limit of this sequence sine n by n, this is actually, this limit of this sequence exists, and we will show that this is precisely 0. Okay, because I have n in the denominator. Okay. So as you can see, sine n is basically, it's more or less, it's less than 1 and it's greater than -1. Correct? Now what I will do, I'll multiply 1 by n. Okay, if I multiply 1 by n, then what I will get? minus 1 by n times sine n by n. This is 1 by n. So as now you can see, as n tends to infinity, okay, this will go towards 0, right? This will go towards 0, and this will also go towards 0. And whatever it is, this basically this thing is basically in between minus 1 by n and 1 by n. So that means this will force this middle term to go towards 0.
0.
Okay. So the limit of this sequence sine n by n, okay, the limit of this sequence is 0. Okay, clear why actually this limit of this sequence is 0?
Yes, sir.
Yeah. Okay,
Yes,
fine.
clear.
Yeah, so for example, if I write like this, let's say sin n plus cos n by n. Can you tell me what will be the limit of this sequence?
0, sir.
Yeah. So why? Because as you can see, like you can basically give the same argument. Like sin n is basically bounded by 1, cos n is basically bounded by 1. So the sum of both the sequence will be bounded by 2 by n. And
2 by n.
this
And
is
here
minus
minus
2 by n.
2n.
So you can apply the same. Yeah.
What if they give tan in place of sine or cos?
Sorry.
What if they give tan n
No,
in place
tan
of
actually
sine or cos?
tan actually you can't use this trick. Okay, because certainly tan x is not bounded.
Okay, then what we have to do in such cases?
Oh, it's depend. What is the exact sequence? So what is your sequence?
Tan n by n.
Tan n by n. So I guess in that case I think the sequence certainly most likely it will diverge, okay, towards infinity, because if you see the graph of this tan x, okay, and one more thing is tan x is basically not defined
Yes.
on whole R, but okay, I guess that won't create much problem because tan x is certainly defined on all the integers, I guess. So let's say this is minus pi by 2, pi by 2. Okay, please mute yourself.
So you will be able to enroll for the January term. The January, February, March, I mean April end पर्यंत exam असेल. So first qualifier is on 26th February. Second, if
Yeah. So as you can see, this is basically the graph of tan x. Okay. Sorry, tan x. Right. So this is actually it's a part of this graph. It's basically minus pi by 2 to pi by 2. Okay. Again, you can because this is actually your asymptote. This is asymptote, and this is asymptote, and again like this is more or less will again like this go like this. Okay. So yeah. So if you take tan n by n, okay. So mostly I guess
So I think can we
Actually,
solve it using
when I
L'Hospital's
graphed it
rule?
on Desmos, and it's looking very weird actually.
Sorry.
I graphed it on Desmos, sir. It's looking very weird actually.
It will be divergent kind of like.
Can we use L'Hospital's rule for solving this maybe?
Why you want to apply, like you basically you want to find the limit of the sequence?
Yes.
No, how you are going to apply L'Hospital rule? Can you tell me?
I'm just curious. Can we do by using that,
No,
or we can't?
L'Hospital rule says like
It
what
is in
I'm
the form
saying.
of infinity by infinity form.
No, it's not in the infinity by infinity form. That is the problem. Like when tan, what is so basically you are saying what will be the limit of this thing, right? Tan
Yes.
x
Mm-hmm.
by x.
Yes.
Correct or not? So this thing certainly will go towards infinity, right? But you
Mm-hmm.
don't know what will happen to the above one, right?
Yeah.
Yeah.
And so
So
above one is not continuous as well.
yeah. So that certainly you don't know. You only when you can apply when you are getting basically infinity by infinity form. Okay. So as I said, like as from the graph, it's more or less looks like, as you can see, it's also it's sort of kind of oscillating thing, right? It's you can see you are getting this one. Okay. So again you are getting the same thing, right? So after a certain interval, you are getting the same thing. So most likely, as I said, if you take this sequence, okay, tan n by n, okay. So most likely it will oscillate, okay. But I'm not sure whether it will go towards infinity or not. Okay. So that
So basically, this is not a sequence at all, right? It will not have values defined at certain points of n. I mean, at certain values of n. This
no.
is not
Actually, the
defined.
problem is here. Okay, so this minus pi by 2, pi by 2. Okay, these are
Right.
not
But for
linear.
natural
Yeah,
numbers, it
this
is
is
defined.
that is not.
The-
But a
these are
sequence for all natural numbers, it should be defined. So this is
Yeah,
the
but
function.
but okay. So these are not natural numbers, right? Pi by 2, minus pi by 2, 3 pi by 2, or 4, 5 pi by 2. These are not natural numbers. So it doesn't matter uh, whether this function is not defined at these points. We only care about natural numbers, right?
Okay.
Yeah. So okay, like I feel like it's more or less it's going to oscillate, okay, because certainly tan n is not a bounded function. Okay, so you one thing I can assure you that this sequence mostly it won't converge. It won't converge. Okay. But again, like to get the precise answer, I guess we need more discussion on this. Okay, so let me move to this limit. Okay. So again, like yeah, so let me briefly recall like how basically we compute limit. So suppose
Hello.
yeah.
Sir, there is this one question given in the March quiz on sequences. I have doubt in that. So if you
Yeah, I'll
have
come to
answer to
that.
that.
In the end, I will come to that. Okay.
Okay.
Yeah.
Okay. Thank you.
Yeah. So the thing is, what suppose I have a function. So basically, what actually we need to we do when we want to find the limit of some function. Suppose I have a function like this. Okay. So what actually we check. Suppose this is a point A. Okay. A point A. We want to check the limit of this function at this point A. So here what we do? We try to find the right hand of the limit of the function. Like we need to check where the value of the function approaches when we are coming to A from the right hand side, right? So in that case we write A plus. So as x goes towards A from the right hand side, we need to we check where this f of x is going. Okay, so we need to check where this f of x is going. So this will give me the right hand limit. Okay, and what the next thing we check? We check the left hand limit. that is when we are coming to a from the left hand side, that is x is going towards a negative. That means this basically this means we are coming to a from the left hand side of the a. That means we are coming to a using the values that are less than. Okay, that is what, right? All the in the left hand side you have numbers which are less than or equal to a. Okay, and we see when we are coming to a from the left hand side where this f of x is going. Okay, so this will give me the left hand, right? So to find the limit we need to find two things. Okay, so to find the limit we need to find the two things. One is left hand limit. Okay, this is, let's say, IL, left hand limit, and this is IR, right? So we need to find two things. If these two things matches, okay, if these two things matches, if my left hand limit at a is same as the right hand limit at a, okay, at x equal to a, then we say that the limit of the function exists. Okay, so then we say that the limit of the function when this limit x tends to a minus, that is what we use for left hand limit. Okay, f of x, this is just a notation, is same as the right hand limit. Then we say that the limit of this function at a exists. Okay, when these are two different things, then we say that the limit doesn't exist at that point. Okay, so that is how we define limit. Okay, so now we have this function, right? So this is, as you can see, this is a piecewise function. Like if x is less than or equal to 2, the value of the function is x, right? So, and if x is greater than 2, the value of the function is 5, right? I have two set of condition in two set of domain. Okay, so as you can see, if I draw the graph of this function, okay, let me draw the graph of the function. So it's saying if x is less than or equal to 2, let's say this is my 2. Okay, well, let's say this point is my 2. Let's say this is 2. This is 2, right? So if x is less than or equal to 2, what is the value of the function? This is x. So can you tell me what will be the graph of this function in this
It will
part?
be a 45-degree line till the 2, and then a straight line from that y at y.
Passing through 0, 0.
Correct?
Yes.
And what will be the, so in this part, if x is greater than 2, the value of the function is 5.
5
right?
constant.
So
straight
then again, certainly, yeah, it's a, even this is also a sort of straight line. Yeah, this will be parallel to x axis, right?
slope will be 0.
Yeah. So here, this is my 5 point. Okay. So from here onwards, graph will be like this. Okay, so this you can see, this will be the graph of this function, and this point, actually here this point is included. Okay, because at 2 the value of the function is actually 2. F of 2 is 2 because it says f of x is x if x is less than or equal to 2. That means f of 2 is 2, and this point is not included. Okay, so this point is not included. Okay. This is not 5. F of 2 is not 5. F of 2 is 2. Okay. So what is our task? We need to find the left hand limit and the right hand limit of this function at x equal to 2, right? So can you tell me what will be the left hand limit of this function at x equal to 2?
2, sir.
2.
Right? It's okay. So let me quickly tell you why. Because as you can see, when you are so what in the left hand limit, what you do, you try to find the limit of the function when actually you are approaching to 2 from the left hand side of 2, right? So as you can see, when you are coming to 2 from the left hand side of 2, right? And when you are coming to 2 from the left hand side of 2, the value of the function, as you can see, it's basically it's approaching towards this thing, right? 2, right? So the left hand limit is basically 2, right? So limit 2 minus f of x is 2. What about the right hand limit?
5.
5, sir.
5, right? Because this with the same logic, you can argue with the same kind of logic. So when you are coming to 2 from the right hand side, right? This is your right hand side, and as you can see, the value of the function is actually coming towards 5, right? This is my value of the function, and this is basically I'm coming to 2 from the right hand side of 2, and during that period, as you can see, the value of the function is basically 5. So we are getting, so my left hand limit is what? 2, my right hand limit is 5, right? So it's clear both are different, right? So in that case, the limit of the function R2 doesn't exist. Is it clear now?
Yes, sir.
Yeah.
Yes, sir.
Okay, so yeah, so let me do more questions. So again, like these questions, so for this question, so you have to make sure that when you are, so when you have so the, for example, if you see, to find out the limit of the function at 2, so here, as you can see, you can't substitute simply 2. Okay, if you compute f of 2, then certainly you will not get the limit of this function at x equal to 2, right? You will not get, because certainly they don't match. Okay, so you are getting something else here. Actually, limit doesn't exist. So if you find out the value of the function at 2, certainly it won't give you the limit of the function at x equal to 2. But in certain cases, for some special cases, you can find out the limit of the function at point A simply by substituting A in that expression. Okay, so when you have, so suppose you want to find the limit of the function, suppose limit x tends to A, suppose you have p of x by q of x, right? And remember that here px and qx both are polynomial. Okay, both p of x and q of x, they are polynomial. Okay, so when they are polynomial, okay, and one more thing you need to make sure that and q of a is not equal to 0. That you need to make sure. Okay, in that case, this limit is nothing but p of a by q of a. Is it clear? So first thing you need to check, okay, like this is p of x and q of x both are polynomial. Okay, even like you can certainly you can generalize this, even it's nothing special about polynomial. Even if p of x and q of x are both continuous. Okay, certainly I am not discuss about continuous function, but let me tell you, if both p of x and q of x are continuous function and q of a is not equal to 0, then basically this limit is nothing but p by a by q. So okay, so now let me apply this thing over here. Okay, for question number 1, can you tell me now what will be the limit of the of the function which is given in option 1?
If we substitute, it is 0 by 0.
It's 0 by 0.
So the limit of the function is
Yes,
0.
Minus 8.
Minus 8. If we directly substitute, it is 0 by 0, and then by Allah's potential root is
Yes,
minus.
minus 8.
So the thing is, the only thing so here certainly I have px and q by x. So the only thing I need to check to directly apply this thing, I need to check whether q of a is non-zero or not. So if I find out q of -1, then basically I am getting 1 minus 3 plus 2. Okay, so this is 0, right? So I can't directly apply this. Okay, so instead of that, what I will do now, so this is what? This is x square minus 6x minus 7. Okay. Two, right? So I can factorize the above polynomial, right? What will be the factorization?
X plus numerator is
Minus
x plus 1 and into x minus 7.
Minus 7x minus 1,
X
minus
minus
x.
7,
X
x plus
square
1.
minus 7x minus x minus 7x.
X plus 1, x minus 7 are the factors of the numerator.
X
Yeah.
plus 1.
X
minus
minus
7.
Correct. Yeah. What about the denominator?
X plus
X
2,
plus 1, x plus 2.
plus 1.
X plus 1 times x plus 2.
X plus 2.
Yes, sir.
Right. So now what I can do, I can
cancel x plus 1, x
Cancel
plus
out
1.
x plus 1 and x plus 1.
yes. So you can
Now
cancel.
substitute the value of minus 1.
Now
minus
you can
8.
so now you can substitute
Substitute.
minus 1. Okay. So now if you substitute minus 1, so what you will get? You will basically get minus 8, right?
Yes,
Because
sir.
this
Minus
is basically minus 8 by 1, which is basically minus. So yeah, so in some case you have to check like whether you can directly apply it or you just need to do little more factorization and whether you have to cancel some of the term factors. Okay, that you need to check. Okay, so that's what I said. You first
Sir, I
need
have a
to check
question.
whether q of a is 0 or not. Yeah, what is your question?
Sir, should we do this? I mean, solve all for all undeterminate 7 undeterminate quantities like this?
No, I didn't get it. Like, can you repeat?
We are solving 0 by 0 undeterminate quantities, and there are 7 such that undeterminate quantities like 0 by 0 infinite. So this is the way to solve all 7 of them.
All 7 of them means 7.
I mean, this is one undeterminate quantities, and there are 7 like that. I mean, such undeterminate quantities. So this is the way we should solve all the 7.
No. This is certainly it won't work with all others determinant. See, this is actually it's some sense you have polynomial and you have 0 by 0 form, so you can factorize it. Okay, and you can cancel it. So if you have some sin x or cos x, you can't apply the same thing there, right? You can't factorize them, right? They are not polynomial. Since this is a polynomial, you can apply this.
Okay, the form will change.
Yeah.
Okay,
So in
thanks, sir.
option 2, as the denominator is not becoming 0, I mean qx is not 0, so we can directly apply the limit in option 2.
Yeah, because as you can see for option 2, as you can see, if I just simply substitute 0 over here, then I'm getting 2, right? So
minus 7.
no, what I'm saying, here.
Minus 7 by 2.
Yeah, correct.
Yeah.
Yes.
So this is non-zero. So direct I can substitute. So direct I can take p of 0 divided by q of 0. So the limit will become p of 0 by q of 0.
Yes.
Okay.
So one idea, one thing, sir. So conversely, So like generally when I do that, okay, that is for x tends to infinity. Okay, sorry, sir.
Sir, one doubt, sir. Sir, now after substituting directly, suppose you are getting an matlab indeterminate form, then you factorize it, and then also you are getting it. Then you do L'Hospital's rule, is it?
Yes, yeah. No, okay, so I'm not talking about L hospital
Okay,
rule.
fine.
Yeah, you
Okay,
can
sir. Okay.
see L hospital rule actually it's much more general. See, now I'm dealing with what? Polynomials, right?
Okay,
As you
okay.
can see, all my so as I said, like when you have sine x by x, so maybe say sine x, right? So I can't factor, right? I can't factor sine x, right?
Yes,
So,
yes.
so that is completely different. So in that case, that is what I am saying. This L hospital rule is much more general thing. Okay. So that
Okay.
actually you can even apply for sin x as well as for the polynomial. But so as you can see, when I'm saying that -1, see here when I said this is uh, basically minus, if I substitute -1, then I'm getting 0, right? So then
Zero by zero.
yeah, so then actually what I'm doing, I'm factorizing it, right?
Yeah, yeah.
But I can't factorize sin x, right? Or
Correct.
maybe some other things, let's say ex or
Okay.
something else. So that I can do. So in that case, actually, I need to apply this L hospital. Oh, even here
Oh,
also you can apply L hospital. Okay, so L hospital is much more general. But this trick, whatever I'm doing now, you can't do it for all the functions. So only
okay.
you can apply for let's say polynomials. Okay.
Okay, sir. Thank you.
Yeah. And similarly, for option 3 also you can do the same thing, right? Option 3 also you can
Yes.
because this is basically by 1, right? And the whatever I have in the denominator, it's always non-zero, right? You can just substitute the value and you will get the same thing. And again in for
Option
option
3 is
4,
correct.
yeah, maybe it's correct. You just need to
Yeah, sir,
substitute
it's
2.
correct. I've solved.
Yeah. Yeah. So similarly for option 4, you can see you are again in trouble because if you substitute 3 here, then you are getting 0, right?
Yes.
So again, you need to factorize it. So if you factorize, actually it's basically x minus 3 whole square, right? And the below one is x minus 3, right? So then basically we are getting x minus 3. And if you substitute, then what you will get? You will get 0.
Zero.
Yeah. Okay, so that is actually the difference uh, for like as you said you can for polynomials actually you can do it you actually you can do it little easier. Okay. But for some arbitrary function you have to you need to apply this L hospital rules. Okay. Is it clear now? Yeah.
Yes,
Yes,
sir.
sir. Sir,
Hmm.
L
Sir, one
hospital rule is
observation.
basically.
Sir,
Hello?
one observation.
Hmm.
Whenever this limit extends to some minus a plus a, whatever it is, in polynomial by polynomial, we
Hmm.
observe that, for example, when x tends to -1,
Hmm.
actually one of the factor will be +1, and limit tends to 3, we can see one of the factor is x minus 3. So you can always first you can factorizing immediately you can think of that. Just an observation, sir.
Hmm.
Yeah, that is what like so when actually you are getting 0 by 0. Okay, so as I said so here if you see as x tends to -1, so this is 0, right? This is 0. If you directly substitute, it is 0, right? And this is also 0, right?
Yes.
So
Sir, we
in both.
use L hospital rule in limits or some other.
Okay, so just
I mean,
just just give just let me complete like so that means so when actually you are putting this value -1, you are getting 0. That precisely means that for polynomials x plus 1 is a factor. Okay. So that precisely means that this x plus 1 is a factor. Okay. So if p of 1 is p of a is if p is a polynomial and p of a is 0, that means x minus a is a factor, right?
Correct. Yes.
So that's it.
Okay.
Okay. Any other questions?
yes, sir. Sir, L hospital rule is basically used in limit or some other.
Now you use it for limit. Okay.
Only
find
for
out the
limit
limit.
sum.
Yeah. So when you have some indeterminate form like 0 by 0 form or infinity by infinity form, okay, for these cases you can apply the L'Hospital.
Okay, sir.
Sir,
Hmm.
sir, if is there the in option 1 the limit is x tends to -1, then we can directly apply that -1 in the instead of x. We can apply -1 or 1.
Sorry.
Yes, we will have to apply -1, but
Can you?
since it is 0.
I didn't understand your question. Can you repeat, Yuvraj?
I was asking that its limit tends to -1. Then x we have to apply in instead of x -1, right? Yes, sir. That am.
But the problem, as I said, like you need to check
Yes.
whether Q of A is non-zero or not. But in
Yes,
this
yes.
case, Q of A is basically 0. So you can't directly apply it. You need to factorize it again, and then you
Yes,
can
sir.
apply it.
Understood. Yeah. Okay.
Okay, so again, like as I have already discussed this sort of sandwich version for sequence. Okay, this how we can apply sandwich principle, and we can easily get the limit of the sequence. Okay, similarly, we have such things for limit of function as well. So for example, suppose I have two function f of x and g of x. Okay, I have two functions. Please mute yourself. Uh, I have two functions. Let's say f of x and g of x. Bhaskar, can you please mute yourself?
Yes.
So suppose I have two functions f of x and g of x, and I know that limit of as when x tends towards a, the limit of both the functions are precisely L. Okay, so limit of these two functions are precisely L. Okay, so if somehow I can find, if suppose I know there exists one more function h of x, which is in between g of s, f of x, right? So if I know that limit of this function, okay, so limit, if I know that limit as x tends to a, this is L, and limit x tends to a, this is also L, then by just by knowing these two things, I can certainly I can say that what will be the limit of this function at x equal to a, because as you can see, this function is basically in between these two things, right? In between these two things. So when this h of x is sandwiched in between f of x and g of x, by knowing the behavior of f of x and g of x at x equal to a, I can certainly tell about the behavior of h of x at x equal to a. So that is basically this sandwich principle. Okay, so if so again, one more thing you need to know, that this limit, the limit of this and this should be same. Okay, then only you can say that the limit of h of x is L. Suppose this limit is, let's say, 5 and this limit is, let's say, 9, then in that case you can't say anything about the limit of h of x. The only thing you can say that if the limit exists, then it will be in between 5 and 9, but you can't give the precise value. Okay, but if this limit is 5 and this limit is also 5, in that case you can say that the limit of this function will be 5. Clear? Any problem with the understanding the?
Yes, sir.
Yeah. So yeah. So now we just need to apply the sandwich principle to find out the limit of this function at x equal to 0. Same logic, like whatever we have done for this sequence sin n by n, same kind of thing we just need to do it here. Can one of you help me to do this question?
We know cos x is bounded between -1 and 1. So inverse of that is again bounded, both same. Then you multiply by x square. So this will be.
So what I have? Cos 1 by x, right? Correct or not? Cos. So what? So can you tell me what? So can you tell me the range of cos 1 by x? So cos 1 by x is always less than or equal to
1.
1. Right? Because certainly cos x is less than or equal to 1, right? So x varies over all the real numbers, right? So cos 1 by x will also be less than or equal to 1, right? And similarly, what I can write for the lower bound, cos 1 by x will be always, hello, am I audible?
-1.
Minus 1, right?
-1.
Yeah. So what I want here, instead of cos 1 by x in the middle, I want x square times cos 1 by x, right? X square times cos 1 by x. And you know that x square is always positive, right? So x square is always positive. So if I multiply x square, then certainly it will not change the it will not change the order of this inequality. Okay, so this is basically x square cos 1 by x, right?
Yes, sir.
So now it's clear, right, how you can apply this limit.
When x tends to 0, x square also tends to 0. So x square cos x is in between my 0 and 0. I mean, both the limits are 0. So in between x square cos 1 by x also will tend to 0.
Correct. So now you can see as x tends to 0, this limit is going towards 0. And this limit is also going towards 0. And I have this thing which is basically in between these two things. So from there itself, I can say that this limit will also go towards 0. Okay.
But here, sir, actually the main challenge was to think that if cos x is less than 1, then cos 1 by x will be bounded between -1 and 1.
No, cos x, okay, that is not a big thing. So see, cos x is basically cos, if you are saying cos x, x varies over all the reals, right? X varies over all the reals, right? So if you take 1 by x, then that is also a real number, right?
Yes.
So then cos 1 by x will also be less than or equal to 1, right? Because I'm just changing some notation, that's what, right? I'm not changing the function, I'm just changing the notation. That's
Yes.
so sin x is less than or equal to 1 means sin 1 by x will also be less than or equal to 1, because I'm just, so this x basically it varies over all the reals, right? So if x varies over all the reals, and here also x varies over all the reals, that means 1 by x will also be a real number. Okay, you are not going to somewhere else. If you take 1 by x, then also you will get some real number. So that question number 6 is clear?
Yes.
Yeah. Okay, so again, like since we have already discussed limit, okay, so this continuity is more or less same thing. So for the continuity, you just need one thing extra. Okay, so so once you know how to check the limit for continuity, you just need one thing extra. Okay, please mute yourself. Okay, so as you can see, actually what you are doing, so you are checking left hand limit and you are checking right hand limit, right? You are checking left hand limit and right hand limit. Okay, if they are same, then you can say that the limit of the function exists. Okay, so this is basically you need to these two things you need to check. Okay, for to say whether the limit of the function at that point exists or not, you need to find left hand limit and right hand limit, and you need to check whether they are equal or not. Okay, for continuity, okay, what you need to check, suppose first you need to check whether the limit exists or not. Okay, if the limit doesn't exist, then the function is not continuous. Okay, if the limit exists, okay, if the limit exists and both left hand limit and right hand limit are same as f of a, the value of the function at that point a, then you say that the function is continuous. Okay, so you basically you need to do one extra thing. Okay, so once the limit exists, that is left hand limit and right hand limit are same, you just need to do one more extra thing, that you need to check whether whatever you are getting, that left hand limit and right hand, whether both are equals to f of a or not. Okay, if they are equal to f of a, then the function is continuous at that point. If they are not equal to f of a, then the function is not continuous. Okay, clear? The definition is clear?
Yes, sir.
Yes, sir.
Yeah. Okay, so for this question, we just need to check the continuity. Okay, so can you tell me what will be the left hand limit of this? Because before checking continuity, we need to find the left hand limit and right hand. Can you tell me what will be the left hand limit of this function?
-1.
At x equal to 0, I'm asking.
At x equal to 0, it will be 0, sir.
Zero, sir, zero.
Right hand, left hand, and the other limit. Everything is 0.
So this is the left hand limit, right? This x square by mod x, right? And so what we are doing now, we are coming to 0 from the left hand side of 0, right? That means my x value of x is negative. Okay, so this I can rewrite as x tends to 0 minus x square divided by minus x, because if x is less than 0, then modulus of x is basically minus of x. Okay, so this is what limit x tends to 0 minus of x. Okay, so x square, basically x square by minus. And as you can see, this if x is going towards 0 from the negative side, this also minus of x also will go towards 0. So this is my left hand limit. Okay, and similarly you can check that the right hand limit is also 0. So instead of minus x here, what you will get? You will get x square by x. Okay, so instead of minus x here, you will get x. So eventually you will get 0. Okay, so the left hand limit and right hand limit exist. That means the function is, the limit of the function at x equal to 0 exist. Okay, and for continuity, what you need to do? You need to check whether these two things are same
Function
as
value is same.
f of 0 or not. Whether this is same as f of 0.
Yes, sir.
Yeah, so that means this is continuous. Suppose instead of 0, if I slightly change this function, suppose if x at x equal to 0, the value of the function is 1. So in that case, whether this function will be continuous at
No,
x
sir,
equal
it
to
is not continuous at 0. It will not continue.
correct, because left hand limit, right hand limit, sorry, left hand limit is same as right hand limit. Okay, but this is not equals to f of 0. Okay, so in that case,
Sir,
this function.
can we say f of 0 to be middle hand limit MHL?
What is middle hand limit? There is nothing called middle hand limit.
Okay, sir.
Yeah.
Sir, I have a doubt.
We solve this by
Why-
taking
while we are
exponential. Okay, you go.
Okay. So while we are considering the left hand limit and right hand limit, for the function for x, we are having in the denominator mod of x. So while considering the limit, we should not consider the mod.
Why?
So
We are
like for
Hmm.
then you have given that the left hand limit is minus x like.
Because so what do you mean by left hand limit? Like, so this is 0, right? So left hand means we are coming to 0 from the left hand side of 0.
So I had the same doubt, but it is
Right.
mod. But anyway, should you not keep it positive, whatever it is?
Just a minute. Let me.
Even I have the same doubt, sir.
Okay, so you don't have to say it. Let me complete the argument. Like why? So someone said like initially someone was talking. So do you agree when I'm talking about the left hand limit at 0? I'm basically coming to 0 from the left hand side.
Yes, sir.
So that means what will be the value of the x at that time? This is negative, right?
Yes.
So that means value of x is negative, right?
Okay.
So when value of x is negative, what will be the value of mod of x?
Positive.
Positive.
This is basically minus of x, right?
Minus of minus x.
Right? If x is negative, mod of x is basically minus of x. Correct or no?
Minus of minus x, sir.
No.
Yes, yes, sir. It's coming from left side.
If you take minus 2, okay, and if you take minus of minus 2, then what you will get? You will get minus 2, right? Which is incorrect. So what you are saying?
No, sir. Actually, it is if it is minus 2, mod of minus 2 is minus of minus 2. So net is plus 2.
So basically what you are taking then? So when you are saying minus of minus 2, then what you are taking? Basically this is what? Minus of
Minus x.
No, minus of x. What is your x here? X is basically minus 2, right?
Okay, sir.
When
Got
x,
it.
so got it, right? So when x is negative, the modulus is basically minus of x.
Whatever is inside the modulus, that is what we are telling as negative.
Yeah. So this whole thing is actually x. So minus, when I'm saying minus of modulus of minus, so my x is basically minus 2, right?
Sorry, now modulus, should it be taken as minus of that value or minus of minus x? Why did we take it like that? Because modulus is just the weight of that one, right? Without the sign. Why do we have to say it as minus of minus 2? Anyway, it is plus 2.
Yeah, because that is how you define modulus. That is how it's, if I write this modulus of x, so when x is negative, if I can write this modulus of x as minus of x, so that is useful when I want to compute the limit. In that case, this is really useful. Okay, that is what I have done here, right? This modulus of x is precisely minus of x. Okay, and that's why I can find out the limit very smoothly. Okay, if I write just simply as modulus of x, then I'm basically in some sense I am in trouble. Okay, I can, if I have modulus of x here, I can't simply cancel it out. Okay, so that is the problem. So when x is negative, so that's why I have divided these two things into two different cases. So when x is negative, modulus of x is precisely minus of x. Okay, and when x is positive, modulus of x is what? It's precisely x, right? That is modulus of 2 is what? This is 2. We are simply writing 2 here. Okay, and when x is negative, let's say minus 3, this is x. X is completely minus 3. And in that case, modulus is basically what? Minus of x, which is what? Minus of minus 3, which is 3. Okay, so this definition is very useful, right? You need to apply, you need to use it lot of times. Okay, Abhishek Kumar. Yeah, what is your doubt? Okay, so let me go to, okay, so this part is clear, right? This question is clear now, right? Why the limit of this function is 0.
Yes, sir.
Yes,
Yes,
sir.
yes.
Yeah.
Yes, sir.
Okay. Naren, yeah. Naren, what is your doubt?
Yes, sir. For differentiability also,
Hmm.
we say that f of x should be equal to f of a. Correct, no, sir? Just like continuity of your spending LHL should be equal to RHL, and that should be equal. Both should be equal. And second condition is it should be f of x should be equal to f of a. So even for differentiability, the same condition is there, no, sir? F of
No,
a
no.
should be equal to f of.
So the thing is, yeah, but that is not enough. Okay, so what is actually, okay, I'll come to differentiability. I'll come just after continuity, I'll come to differentiability, and at that time, see, if a
Okay,
function,
sir. Okay, sorry, I'll wait, sir.
So if a function is continuous, okay, if a function is continuous at x equal to a, okay, that means the limit of this function at a exists. Okay, this limit exists. Okay, if f is continuous at a, because that is how we define continuity, right? First, what we check for continuity, what we check? We check whether both the limits exist, and apart from that, if the existing limit, if that is same as f of a, then we say that the function is continuous at a. Okay, so it's clear that if f is continuous at x equal to a, then the limit is exists. But if I know that limit is exist, okay, suppose I know that the limit exists. Okay, suppose I know that from the limit exists. From here, I can't say that f is continuous. Certainly, I can't say the reverse.
The converse is
Sorry,
true.
yeah. So the converse is not true. Okay, so this is basically the converse. Okay, so this statement is true. If f is continuous, that means this implies the limit exists. Okay. But if the limit exists, from there itself, I can't say that the function is continuous. Okay, so as you can see, if you see the above example, okay, if you see the above example, if I change this 0 to, let's say, free, okay, then as you can see that the limit actually exists at x equal to 0, but this function is not continuous. Okay, if you see the limit actually is at 0 is 0, right? But this function is not continuous.
That is, you have the left hand limit and the right hand limit, but it is not continuous.
Yes. Yes.
Okay. Okay.
Yeah. Okay, so that's why, yeah, so you should, so that's just now someone said like the differentiability. So again, like there is a, so if f is differentiable, from there itself you can say that f is continuous. Okay, and from there itself you can say that limit exists. Okay, but if is continuous, that doesn't imply that f is differentiable. Okay, I'll come to that. Okay, I guess this question. Can you tell me how to solve this question? So it's basically we need to find whether this function is continuous at 0 or not. Okay, for that I need to find the left hand limit and the right hand limit. Okay, so can you tell me how I can yeah, so how I can get the left hand limit of this function?
we can't substitute.
Sir, I think we have to use that composition of function.
No,
where
no,
x-
no.
Sandwich principle.
No.
To simplify the equation, we have to multiply and divide by x.
No, that is incorrect.
So
Hmm.
we can define this function in two intervals, greater than 0 and less than 0, and then we can apply limit x tends to 0 positive and 0 negative. Then
Yeah, tell me how that if that is the case,
okay,
how, tell me.
1 by e power 1 by x plus 1 when x is greater than 0,
Sorry,
and
sorry.
1 by e power, it will be, the function will be 1 by e power 1 plus e power 1 by x plus 1 when x is greater than 0, and it will be 1 by e power minus 1 by x when x is less than 0.
It will be 1 by e power
1 by e power minus 1 by x plus 1
if x is what? If x
less
is
than 0.
why?
Less than 0.
Why? Why? If suppose x is minus 2, right? If x is minus 2, this is less than 0, right? This is less than 0 or not? Then
Yes.
what is the value of this function f of minus 2? This is 1 by e power
1 by 2. 1 by
plus
2.
plus 1, right?
Plus 1 by, yeah.
Yeah.
Plus 1 by 2, sir.
But this is the value of the function e power 1 by x, f 1 by e power 1 by x plus 1. But what you are saying, if x is less than 0, you are saying something different. So if I substitute x minus 2, you are saying basically e
No,
power
sir,
minus.
you have, sir, sorry to interrupt. It is 1 by e power plus 1 by 2, because negative will become positive, no, here. F of minus 2 is equal to 1 by e power plus 1 by 2 plus 1. Minus of 1 by x is plus 1 by x ho jayega when you substitute minus 2.
But that is not how I define this function. This function is what? 1 by e power 1 by x plus 1. So what if I substitute f of minus 2, what I will get? 1 by e power minus 1 by 2 plus 1. Yeah, this is the value of the function at f of minus 2. But whatever you are saying is incorrect. This is not
Okay,
the value
okay.
of the function. So basically you said that okay, so whoever said that if
So
x is less than
when
0.
Yes, sir. Yes,
so
sir.
when
It is
x is 0
not correct.
minus, it can be written as e power 1 by 0 minus. So it may be e power minus infinity. So e power minus infinity tends to 0 from the
Yes.
graph of e power x.
Yeah, correct. So yeah,
That
you
is
are.
for 0 minus. And for 0 plus, e power infinity tends to infinity.
Yeah.
Yes, so it becomes 0. The function value becomes 0.
Not function value, the right hand
The
limit.
Right hand limit,
left and
sorry.
right
Yeah,
limits
right
are
hand.
not equal.
Yeah.
Yeah.
Absolutely correct. Yeah.
Like,
Absolutely correct. Whatever you have said, yeah, it's absolutely correct. So, so the thing is one. So again, like let me explain what basically she was trying to say. So, so as you can see, I'm finding the limit, the left hand limit, right? So that means the 0 I have here, and I'm coming to 0 from the left hand side of the 0. Okay, that means x is negative, right? X is negative, right? And x is coming towards 0. That means 1 by x will go towards where?
Infinity. If x is going to 0.
Sorry?
minus infinity.
Minus infinity.
Minus infinity.
Yeah. So that means e power 1 by x will go towards
0.
0. Right? And that means e power x plus 1 will go towards 1, right? So that means the left hand limit of this function is precisely what? This is okay, like you, I can take the reciprocal. In that case also it will go towards, okay. So that means the left hand limit of this function is what? 1, right? Clear why the left hand limit is 1?
Yes, sir.
Yeah.
Yes.
Sir,
Okay.
excuse me, sir. So the same question is given in activity 8.1, wherein the options are the left hand limit is not equal to right hand limit. The left hand limit is equal to right hand limit, and f is continuous at x is equal to 0, and f is a bounded function on R. So here left hand limit is not equal to right hand limit, correct? But what is f is a bounded function on R? So is it true or?
I'll come to that. Okay, so just allow
okay.
me to complete one question. Okay.
Okay,
So
the same question, sir. This is the same
yeah,
question
that is what there, from there only I took that question.
Okay, okay, sir. Okay.
So I'll come to that question. Okay, if it
Okay,
is
sir. Thank
bounded.
you.
I have already discussed this question. I remember in maybe probably in some session. Okay, so what about the right hand limit? So right hand limit, if you see what in case of right hand limit, what we are doing, we are coming to 0 from the right hand side, right? That means x is positive, right? That means x is positive. So if x is positive, then and x is going towards 0, then you can see 1 by x will go towards where?
Infinity. Positive side.
Right?
Yeah.
So that means e power 1 by x will go towards.
Sir, but just one thing I wanted to ask, sir. When we are, whenever we have 1 by 0 form, we are saying that it's indeterminate. We are not saying that it's going to infinity, right? So, but here you are saying 1 by x, when x tends to 0, then it's going to infinity, but isn't that contradictory?
No, here it's not in infinity by infinity form, right? Here,
but whenever we are getting the form 1 by 0,
just allow me to complete my statement. So here if you see, this is not in indeterminate form, right? This is, I have 1 in the denominator, okay, and here I have something completely different thing. So this is, as x tends to 0, it's in some case it's going towards infinity, right? And in some case it's going towards some other thing that is precisely 1, right? So this is certainly, it's not in indeterminate form. Indeterminate form is where when both numerator and denominator both are going towards 0 or both are going towards infinity. Okay, but this is not the case for this question.
So sorry, sir, to interrupt you, sir. When x tends to 0, e power 1 by x is what, sir, actually?
X tends to 0.
Yes, sir.
Yeah, that is what we are trying to find, right? Because as you can see, when x is going towards 0 from the left hand side, okay, we are getting that e power 1 by x is actually basically going towards 0, right?
Okay, 1 by x is what, sir, actually? When x tends to 0, 1 by x is?
It's clear, right? If x tends to 0, 1 by x doesn't exist, because when x tends to 0 from the left hand side, right, your 1 by x is basically going towards minus infinity, right? When x is going towards 0 from the positive side, then your 1 by x is going towards plus infinity, right?
Okay, sir.
That is what we have computed, right? If x is going towards 0 from the negative left hand side, 1 by x is going towards minus infinity, right?
Okay. Okay,
When
sir.
x is going towards 0 from the right hand side, 1 by x is going towards plus infinity.
Okay, sir.
Sorry to disturb, but just one thing, as far as I understand, Division by 0 will not be defined now.
Sorry?
Division by 0 will not be defined.
No, division by 0 is not defined. I agree.
So 1 by 0, how we are telling that it will go to infinity?
Where I have written 1 by 0, can you tell me? Where I have written 1 by 0? Huh?
When x tends to 0 from
X tends to 0 is different from 1 by 0. I'm saying x tends to 0, right? That means x is going towards 0. So I'm not saying that x is precisely 0. 1 by 0 is not defined, right? 1 by 0 is not defined. I'm not saying that here x is 0. What I'm saying, x is going towards 0, right? X is going towards 0. I'm not saying that x is precisely 0. There is a difference, right? I'm coming towards 0. Okay.
It's only tending to 0.
1 by 0 is not defined. That is correct. But I'm coming to 0 from, so my x is basically, let's say, 0 minus 0.1, okay, minus 0.01, minus 0.001, minus 0.00001. So in this case, I can write 1 by, so I can write 1 by minus 0.1, that is minus 1 by, sorry, 1 by minus of 0.01. Okay, these I can write. I'm certainly, I'm not saying that I'm not writing 1 by 0. I'm writing some number 1 by x for those numbers for which x is very close to 0. Okay. So there is difference between these
I
two things.
understand. Thanks.
Yeah. Okay, so e power on 1 by x, okay, again, like, let me, so when x is going to 0 from the positive hand side, 1 by x will go towards plus infinity, e power 1 by x will go towards plus infinity, and 1 plus e power 1 by x will go towards plus infinity. And similarly, I can write 1 by 1 plus e power x will go towards
infinity.
No infinity, it will go towards 0. Okay, because see, this if this number is going towards infinity, okay, so then reciprocal of this number will come towards 0, right? So as you can see, my left hand limit is 1, right? This is my left hand limit, and my right hand limit is 0, right? So right hand limit is not same as left hand limit. That means the limit of this function at 0 doesn't exist. Since the limit doesn't exist, from there itself I can say that the function is not continuous. Clear? Why this function is not continuous?
Yes, sir.
Yeah, so only one thing remains is basically to show that the function is bounded or not. Okay, so this is more or less easy. So you can see e power x, it's always greater than equal to 0.
Yes, sir.
Yes, sir.
Yeah. So e power 1 by x is also always greater than equal to 0.
Yes.
I'm just changing the notation. That's all. If x varies over all reals, 1 by x also varies over all reals. Okay. I'm not writing anything else. Okay.
Sir, it's 0 or 1? E power x greater than or equal to 1 or 0?
It's greater than equal to 0. You can write it as strictly greater than 0. Okay, because e power x is not 0. See, if x is negative, then e power x is certainly less than 1, right?
Yes, sir.
Yeah.
Yes.
It's not equal to 0, right?
Yeah, it's not equal to 0. That you can write. See, it doesn't matter whether you are writing it as greater than equal to 0 or strictly greater than. It's matter of notation. Okay, so 1 plus e power x is greater than equal to 1.
1.
Correct?
Yes, sir.
So now if I write, then if I take the reciprocal, okay, then what I will get? 1 by
1 plus e power 1 by x.
is always less than equal
is less than or equal to 1.
1, right? And you know that this thing is certainly greater than equal to 0, right? Or even you can write strictly greater than 0, right? Because 1 plus this 1 plus e power x is always positive, right? So positive by positive is always positive. So from here you can say that this function is bounded.
Bounded.
The
Okay.
value of the function is always in between 0 to 1.
Okay.
So clear, right? Why this function is bounded?
Yes, sir.
Yeah. Okay, so it's more or less I have discussed about continuity. Okay, let's go to differentiability. So
So there are few more questions in that activity wherein you have the tan inverse of there is a function which involves tan inverse. So how to solve that sums? How to solve that question?
yeah, I'll come to that. Maybe let me complete the things that I have planned.
Okay.
Probably
Okay.
after.
Okay. Okay, sir.
Okay, so for differentiability, okay, so again, like let me tell. So one thing you can say that if f is not continuous, so if f is not continuous, from there itself you can say that f is not differentiable. Just like if limit doesn't exist, okay,
Then function is both
then
not
from
continuous.
here itself you can say that f is not continuous, right?
Yes.
Yes.
Not continuous. So if limit doesn't exist, from there itself you can say that f is not continuous, and from there itself you can say that f is not differentiable. Okay, but if f is continuous, okay, if f is continuous, you can't say that whether this function is differentiable or not. Okay, if f is continuous, from there itself you can't say that whether this function is differentiable. If but the you can tell about the converse. What is that? If f is differentiable, that means
continuous.
Then it is continuous.
yes, that f is continuous. That means the limit
Exists.
yeah. Okay. So yeah. So you can say this. But the converse part you can't say in anything.
So the converse part is need not be matlab it can be or it may be or it may not be, which we have to
yeah.
check.
Yeah,
Okay.
which you need to check separately from
Okay.
that you can. So again, like if limit doesn't exist, then certainly you can say that f is not differentiable. Okay, but if limit exists, from there you can't say whether the function will be differentiable. You have to check.
Okay.
Okay, so let me just recall the definition of differentiability. So suppose you have a function. You say that this function is differentiable at x equal to a if this limit exists. Okay. If this limit exists, then you say that your function is differentiable at x equal to 0. Okay. So that is the definition of differentiability. If this limit exists, this limit exists, then you say that this function is differentiable, and the derivative of this function at x equal to a is precisely this limit. Okay, yeah. So if you have any doubt, please ask me. Okay.
Sir, I can't hear anything and I can't see the board also.
Sir, you're clear, and we can see the.
There is some issue with Radha.
Yeah, I guess you please try to reconnect maybe.
Okay.
Yeah, so this limit, basically if the limit exists, this limit exists, then basically we denote this limit as f dash of a. Okay, this is basically the derivative of this function at x equal to a. If the limit exists, okay, if this limit exists, then we denote this limit as f dash of a, that is basically the derivative of the function at x equal to a. Okay. Okay, so one thing is, as I already said, if the function is differentiable, that means if the limit of this function exists, then from there itself I can say that my function is continuous. Okay, so from there itself I can say that my function is continuous. But again, the converse is not. If f is continuous, that doesn't imply that the function is differentiable. Okay. So for example, if you take this function, let's say f of x is equal to mod of x. Okay, so this function is continuous at x equal to 0. This function is continuous at x equal to 0. But you can check that if you compute the limit at x equal to, if you check the derivative, that means if you compute this limit. So suppose you want to check whether this function is differentiable at x equal to 0 or not. You want to check whether this function is differentiable at x equal to 0 or not. So if you now try to apply this formula, limit h tends to 0, f of a plus s. So here our a is nothing but, so here our a is nothing but 0, right? We are checking basically the derivative of the function at 0, right? So if I compute the derivative at x equal to 0, then this is precisely f of 0 plus s minus f of 0 by h. So this is nothing but limit s tends to 0 mod of h, because f of 0 plus h is basically f of h, and f of h is what? F of h is mod of h. So mod of h minus 0, which is mod of h by h. Now again, now here this modulus thing will like, as I said, I have already said, this mod of h is h if h is greater than equal to 0, and mod of h is minus of h if h is less than 0. Now this will play a huge role to show that this limit actually doesn't exist, because if I take the left hand limit, okay, if I take the left hand limit, then what I will get? So if I take the left hand limit, h tends to 0 minus, then this modulus of h is nothing but minus of h. This is minus of h by h, which is basically minus 1, right? And if I compute the right hand limit, that means this h is positive. So modulus of h is nothing but h. So h by h will get 1, right? So I'm getting two different limits. I'm getting one left hand limit, and my right hand limit value is something different from the left hand limit. Okay, that means this limit doesn't exist. Okay, so that means this function is not differentiable at x equal to 0.
Sir, so we can say that at x equal to 0, two different limits are not equal, so it won't be continuous.
No, this is not, this is continuous. This is not, this is continuous. This is a continuous function. This function is not differentiable.
Sir, limits are not equal.
No, limits of so continuity is different. So again, like what is the definition of continuity? Can you tell me?
Fa function of ax is value of fx at x equal to 0. मतलब both the limits RHL and LHL must be equal, and function of a equals to a limit of
what is the left hand limit of this function f of x is equal to mod of x at x equal to 0? What is the left hand limit?
Minus
0.
0 left hand limit, right? What is the right hand limit?
Zero.
So then why this function is not continuous at x equal to 0?
Here the derivative formula is different.
See, derivative formula is different. So here you can see if I am doing something different, I am taking some I have some. So when I am computing the derivative thing, I have something on the denominator, I am something on the numerator. So don't mix two things. See, continue checking limit and checking differentiability are completely different thing. Okay, you need to apply some to different rule over there. Okay, so
Okay,
this
sir.
actually,
For differentiability, we have to check limits from this formula. If they are equal, then it would be differentiable.
Yes.
Okay.
That f of a plus s minus f of a divided by s. Yeah. That is what you need to apply to check the differentiability. Okay.
So basically, we are calculating the left-hand derivative and right-hand derivative using this formula, isn't it?
Yes, correct. So this limit, basically this is the left hand derivative and this is the right hand derivative. Yeah. Okay, let me go to the next slide. Yeah. Okay, so this, as you can see, this function, as I said, already said, this function is continuous at 0, but it's not differentiable at 0. Okay, so this is okay. This is sort of a standard example to basically to say that to prove this fact that if f is continuous, that doesn't imply that f is differentiable. Okay, so again, like this question, suppose you have a function. Okay, suppose you have a function and you know that this function is continuous and as well as differentiable at x equal to 1, right? Then you need to find the value of k minus 2l plus m. Again, how you should do this?
So first we need to calculate the left-hand limit and right-hand limit, and we know it is continuous, so they have to be equal.
To the value of the function at x equal to 1.
Yeah. At x equals to 1, and then we have to equate both the values, and again
Okay.
for the
Yeah,
left-hand derivative.
I'll come to that. I'll come to that. Let me first complete this thing, whatever you have said. Okay, so what will be the left hand limit of this function at x equal to 0? Sorry, x equal to 1, left hand limit.
K plus L.
Left hand limit, as you can see, x. So when x is less than 1, the value of the function is basically kx square plus 1. So when x will go towards 1 from the left hand side, then the limit will be precisely k plus l. And what about the right hand limit of this function?
L plus k plus m.
L plus k plus m, because when x, so when you are going x from the right hand side, that means the value of x is basically greater than or equal to 1. So in that case, actually this value of the function is precisely lx square plus kx plus 1. So when the value of the function is lx square plus kx plus 1, and when you are going towards 1, so the limit will be l plus k plus m. Okay, and so when I can say that f is continuous, when these two things are equal, and as well as these two things should be equals to f of 1, which is I guess k plus
L.
So again, like we don't have to take these two things twice. So again, we are getting here k plus 1 and also, sorry, k plus l. Here also we are getting k plus. So we don't have to take it twice. So what do we want? So in the end, we want these two things to be equal. This k plus n L and as well as L plus K plus M. So if I equate K plus L, if this is same as L plus K plus M, then from here I can get that M is 0. Right? So, okay, so then I can, since I know from here now, if f is continuous, then M has to be 0. Okay. So from here, I can say that I can basically I can remove this thing because M is 0. I don't want this to be in this expression. Okay. Because if M is not 0, then F can't be continuous. And if F can't be continuous, then certainly F can't be differentiable also. Okay. So M has to be 0. Okay. So then what will the next thing I need to check? I have
the two derivatives, I mean left hand derivative and right hand derivative.
Yeah. Okay, so how you can check?
So it is differentiable, so we don't need to use the limit formula. I mean the principal formula. We can just derivative. I mean take the derivative, like you know, like the way we take derivatives.
Yes, correct. So okay, so now I'll maybe in some sense I'll try to. So suppose the function is differentiable. Okay, so suppose the function is differentiable. If the function is differentiable, then what I should get? F dash x. What I should get? If I derivative this function, then what I should get? I should get 2kx.
2kx, yeah.
2kx if x is
less than 1, less than equals to 1.
1, right? And
2lx plus k.
2lx plus k
if it is greater than 1.
If it is greater than 1. Okay. Right. So now if I take basically in some sense, if I take the left hand derivative, okay, if I take the left hand derivative, what I will get? The left hand derivative, what I will get?
2k.
Left hand derivative. This is basically it's 2k, right? And what will be the right hand derivative?
2l plus k.
This is 2l.
2l plus k.
2l. K will not be there.
Why it's not?
2l.
Why it won't be there? We already have taken the derivative. It's already there. So we are just putting the f, like we are taking f as 1. So yeah, it would be there.
Yeah. So the right hand derivative is basically 2l plus k. So we want these two things to be equal, right? So 2k should be equals to 2l plus k. That means
k equals to 12.
Yeah, this should.
Sir, sorry to interrupt you, sir. Why are we equating these two?
Because see, so the thing is, I know that the function is differentiable, right?
Yeah.
So when the function can be differentiable, when the left hand derivative and the right hand derivative are same, right? So
okay,
so
you
if
can't
see,
have two different values like in mod x.
Yeah. So basically, so in actually, so here as you can see, we have computed the derivative by using the definition, right? In this case.
Yeah.
So if you see, we are getting this. This is my left hand derivative, right? And this is my right hand derivative.
Right hand derivative.
And that's why this function is not differentiable, right?
Okay.
But here it's given that the function is different. So we want this function to be a differentiable function. So then this should be, both the things should be equal, right? So that's why by equating this, we are getting this thing. Okay. So again, like my aim is 0 and 2l minus k is 0. Okay, so if you do something like basically if you compute this, then this also will become, my guess is 0 because k minus 2l is 0, m is 0. Okay, so probably the next thing is how you can compute the tangent. Okay, tangent line. Okay, so this is precisely the formula for the tangent line. So suppose you have a graph. So you have a graph, okay, and this is your function f, let's say. So So why actually, the thing is, why the main idea of this derivative, why actually we are computing the derivative. So this derivative is so at this point, let's say this is my a. This derivative of this function will precisely give you the
slope of the tangent.
Yes, the
At
slope
that
of this. Yeah. So what is f dash a? So if you compute f dash is nothing but it's the slope of this line. Okay, this is the slope of this line. So now what you know that this line basically passes through a comma f of a, right? A comma f of a, that you know, because that is the tangent. Okay, because if you are computing, so the tangent line at a should always pass through this point a comma f of a, and as well as you know the derivative, sorry, you know the slope of that line. So once you know the slope and also you know that this line passes through a comma f of a, then you can easily find out the equation of that line. So this equation is precisely this: y equal to f dash of a times x minus a, okay, plus f of a. Okay, this is the slope of this line. Okay. Again, like, yeah, so to find out that equation of the tangent line is not that difficult. You just so if you know how to find the derivative, then it's basically it's really easy. It's basically finding same as finding equation of a line. Okay. Okay, so let me solve this last question. So suppose f so whatever f, suppose I have f, okay, I have something f, let's say this is x equal to 1. This is the curve of a, and f is differentiable at x equal to 1, right? So this is the tangent line. I know that. Okay, so this should pass through this point. So assume that this is basically passing through this point. So I know that basically what I know, that the slope of this line is nothing but f dash of a, right? I know that slope of this line is precisely f dash of 1, right? And what is given here, if a line, so it is given that if a line which passes through 5 comma 8, okay, it is basically tangent to the curve at 1 comma 0. So this is my curve and this point is 1 comma 0, right? And as well as it passes through one more point. What is that point? The another point is 5 comma 8. So it's asking what will be the value of f dash of 1. Can you tell me how you can find the value of f dash of 1?
Straight line
y2
formula.
minus y1 divided by x2 minus x1.
Yeah, correct. So certainly you know that this line passes through these 2 points, these points and these points, okay? And you just need to find the slope of the line. The slope of the line is precisely f dash of 1. You just need to find the slope of the line. Probably it's 2, I guess. Okay. So
Yes,
any
it
doubt
is
from
2.
question number, from this question?
No, sir.
Okay.
No, sir.
Okay. So now you can
Sir,
start.
Sir, if these 2 points are given, so why should I? Can I not equate the formula from 2-point straight line formula?
But it's not asking you to find the equation of the tangent line. Okay, it's asking you the slope of the tangent line. Basically,
Okay.
yeah.
Okay. Sorry. Clear, sir. Sorry.
Yes. Okay. So yeah.
Sir, here f dash 1 is a slope, sir.
Slope of that line. That is what I said, right?
Oh, okay, sir.
Sir, can you explain one's floor function and seal function, whether it is differentiable at x equal to 0 or not?
So again, like, so the thing is, there is nothing, there is no difference between the argument for the floor function and ceiling function. So this is okay. So this is basically greatest integer function and something smallest integer function. So let me take the case, let's say, for greatest integer function. So what is basically greatest integer function? What is this function?
X. Smaller integer value.
Basically,
if x
which is
is
less than or equal to x.
x.
Correct. So the greatest integer function is basically the greatest integer.
So this is
Integer. Integer less than
x.
Less than or equal to x. Okay. Right. So that means if I take 2.3, then what will be the value?
2.
2. Right. It's basically 2 is the greatest integer which is less than or equal to 2.3. Okay. So so let's say you try to compute, suppose if you draw the graph, then let's say this is 1, this is 2, and this is 3, right? So if I take this, let's say 1.2, then I will get 1, right? So if I take 1.2, I'll get 1, maybe 1.3 also give me 1, 1.4 is give me 1. So if I draw the graph, then this is precisely this thing, right? So in this interval, so basically in this interval, okay, the value of the function is precisely 1. Okay, this is 1. Okay, let's say, and similarly you can check that in this interval 2 to 3, the value of the function is 2, right? So this is a function. So my first question is whether this function is continuous at x equal to 2. Whether this function is continuous at x equal to 2.
It is not continuous because left hand limit and right hand limit are different. Left hand limit is 1 and right hand limit is 2.
Correct. So since this function is not continuous, then I don't have to go and check about the differentiability. Okay, so certainly then this function is not differentiable also at x equal to 2. Okay. And similarly, you can say that actually this function is not continuous at all the integer points, as well as this function is not differentiable at integer points. That you should remember, like it's not differentiable or continuous at the integer points. Okay, but if you check some non-integer point, let's say if you take this one, right, let's say 1.5. Yes, I know. 1.5.
Sir, I mean, you can finish this, then I can ask. I can wait, sir.
Yeah. So in 1.4, if you see actually 1.5 here, actually the both left hand limit and right hand limit, they are same. This precisely 1.5. Okay, this at other point, actually non-integer point, the function is always continuous as well as differentiable, because in that middle part it's basically constant. The main problem is this integer points. Clear this part? Yes. Now, Sayan, you can ask.
Sir, what if we have a sequence including this greatest integer function and we need to calculate the limit? How should we approach that?
Okay, it's depend on the question. Like,
I mean, so let's say we have a sequence, 3n minus float of n by 2.
3n?
3n plus float of n by 2. No, not this one, sir. Not this one, sir. I mean, this is outside. This is outside.
3n
minus a float of n by 2.
floor of
n by 2
whole
divided by 7 minus n, I guess. Yeah, that was the question. 7 minus n. Yeah.
Please mute yourself.
7 minus n, sir. Minus n. 7 minus n.
7 minus n. Okay.
Yeah.
Please mute yourself.
Sir, how to approach this kind of question when we just try to find the limit of this sequence?
Yeah. So the thing is, as you can see, so you just need to divide this into two parts, right? This question is from mock or what?
Yes, sir. Yes, sir. Yes, sir.
We have provided you the solution, right?
But sir, the solution is like kind of confusing sometimes because this is like, I mean, this is one part and there was another part. I mean, it was a piecewise function. So the explanation was kind of confusing to me. That's why I did ask you how to just approach this part, because the other part was pretty straightforward. Like it was square function, I mean quadratic, both in the numerator and denominator. So yeah, that was pretty straightforward. But this part was pretty confusing when I saw the solution. So that's why I did ask you like how to do it, like, you know.
Just a minute. Let me like basically I have. So okay, so in generally what in this kind of question, what basically you do, you basically try to in some sense you try to split the question. Okay, so you try to check how actually this. So again, like if you know, so the only concern over here is this part, right? This is the main problem.
Yes, sir. Yes, sir.
So you just have to get rid of this one, right? So the first thing what you need to do, you need to check if n is even, then what will be the value of this one, right? If n is even, what will be the value of this thing? What will be the value?
But sir, for this question, particularly this question, this was actually for n equals to odd.
No. So I didn't get it. Like this n varies over all numbers.
I mean, sir, for this piece, this piece function, it was the condition was given for n is odd, and the quadratic part that I was saying, that was for the even part.
Okay, can you tell me which question you are talking about? Whether we have released this question?
It is in the mock, sir, but I don't know exactly which question.
Sir, I have an approach for this, if you can allow me. He's saying this is n is odd, it is given. So maybe we can consider, for example, if n is 3, then it will be floor of 3 by 2. That is floor
so that is
1.5. So that will be equal to 1.
Yeah.
So we can say that whenever n is odd, this floor of n by 2 is equal to n minus 1 by 2. Like if we took 3, we are getting 3 minus 1 by 2. That is 2 by 2. We are getting 1, right? So we should replace this n by 2 with n minus 1 by 2. It holds good if n is equal to 5 also. If it is 5, we will get 5 by 2, that is 2.5. And when we floor, it will be again 2, right? So that is 5 minus 1 by 2. So for n is odd, we should replace this with n minus 1 by 2.
Again, like see, the main confusing point is basically he's saying that this is the sequence, and so initially what I was thinking that this is the sequence, and basically I was trying to split this part into two cases. But again, he is saying that this is one part of the question.
Yeah, if this is
Sir,
the
the question
only
is
sequence, then
so the question is mock question number 12, mock 5 to 8.
Yeah, that is fine. Can you, son, can you tell me when n is even, what is this one?
Sir, when n is even,
it is 5n square minus 4n plus 1 by 6n plus 2n square.
Sorry.
If n is even, it is 5n square minus 4n plus 1 whole divided by 6n plus 2n square.
Okay, so 6n plus 2n square. Okay, this part is certainly easy, right? Finding the limit.
Yes, sir. That's exactly what I said. I mean, the even part is straightforward.
So okay, so this is fine. But initially, I was thinking this is the sequence. So I was thinking to split this sequence into two cases. N is odd and n is even. Okay, because if n is even, then actually you will get precisely n by 2, right?
N by 2. Yeah.
So
Sir,
that is what.
Sir, if it was even, so that was pretty straightforward. But odd, in that case, we need to just find the conditions.
So basically, someone already actually answered this question. So the thing is what actually you need to do actually. See, if n is, let's say n is 3, right? What is n by 2 greatest integer?
It's 1, sir.
1, right? And if you have 5 by 2, then what you will get? This is 2.
It's 2.5, sir. 2.
2, right? So now you need to write. So as you can see, this is precisely what? This is precisely n minus 1 by 2, right?
Yeah.
See, this is precisely n minus 1 by 2, right? Because see, the thing is, if you take, let's say, if you take 4 by 2, greatest integer of 4 by 2 is basically same as the greatest integer of 5 by 2, right? Because you are basically, if you divide 5 with 2, basically you will land in between 2 and 3, right? You will land in between. So now, only thing you just need to do, you just need to replace this one with n minus 1 by 2, right?
Okay, sir. I mean, for this specific question, yes, sir, got it.
Now you are basically, now you are done, because the only thing is you just need to get rid of this sign, right? This greatest integer and smallest integer. So now you have this thing n minus 1 by 2.
Sir, can I tell in generalized form? Can I try?
Sorry, what do you mean?
Means instead of taking the values 1, 3 and so on, can I try in generalized form?
That is what the generalized form, right?
Yeah. Means since n is odd, so we can take n as 2x plus 1. Okay. So
n
this
is odd.
expression
N is odd.
Means n can be 2x plus 1.
2x plus 1.
Yes. So this expression will be 2x plus 1 whole divided by 2. This floor
n
function.
by 2. N by 2.
No, x plus 1 by 2. This equals, no, not this. N is equals to x. Yes, correct.
This is
fine.
correct,
right? So it is x plus 1 by 2, right?
Yes, x plus 1 by 2.
Yeah. So from there, we can get that x is
correct.
n minus 1 by 2.
Yeah. So this is same as the greatest integer of n by 2, and this greatest integer of is precisely x. So again, like, see, this is correct. Whatever you have said is correct. So the problem, what will happen actually here, you have to, so again you have to write that this x is nothing but n minus 1 by
2.
Yeah. So finally you have to come back to this. So basically you have gave a perfect mathematical proof that why basically this greatest integer of n by 2 is n minus 1 by 2. Yeah. So again, finally you have to write this thing in terms of n. Okay. If you write some in some other form, then again you will be in trouble and you can't find the limit.
Okay, sir.
Okay. Yeah. So now it's clear, right, San?
Yes, sir. Yes, sir. It's clear, sir.
Okay. Okay. Naranya, if you have any question, you can ask.
Sir, this is regarding that mock. One second. So that 1 second. Mock 5 question number 1. I have seen the answer also. Solution.
Mock 5. Okay. See this week 7, 8, and 9 mock, right?
Small doubt, sir, because that is also talking about limits only. So first question talks about limit, no, sir?
First question is our limit.
Yeah, AN they are given and BN is given. Then in the question it says log. In the solution it says the log they are taken for the whole things. Log based in AN they are given plus AN by 10 minus 7 BN. But when they are considering solution, they are considered as log based on open bracket AN plus AN by 2 minus 7 BN close bracket. How is that right, sir? If you can open that question, you will be able to see that, no, sir.
Just this. Okay, so
how we should consider it?
You are saying the finding when they are finding this limit of Bn, right?
No, I am getting answer as 20 because I have considered AN tends.
Okay.
I mean, limit is 100. So log of
just a minute. Let me. Yeah. I'll come to that. Just let me write the question. Whether I'm writing this question properly because I don't know. This is not parameterized question. I guess this is question is same for everyone. So this is the question, right? And this is two sequence. You just need to find the limit of this one. Log 10 an
close bracket.
Not close bracket. This is basically log
AN is
of.
closed, no, sir. Log AN is closed. After that, you are giving AN by 10. Then minus 7 BN. But for see what I have taken is log of AN only I took. After that, it is AN by 10. How can we consider this log is for all the three expressions? You have
Right? This is what you need to find. Correct or not? So what is the limit of AN?
So maybe give him control to share screen so that he can show properly.
No, this is the question, right?
Yes, sir. Correct, sir. Correct, sir.
No, what someone is saying like I didn't understand. So do you want me to allow to share your screen?
No, I don't want to share, sir.
Okay.
So this is correct. This is the question.
No, sir, the question they are not written as find the limit of the sequence. Okay.
No, fine. In the question, it's written that you need to find the limit of this sequence.
Limit of the sequence, but that bracket is not given. It says log based on AN.
This bracket, even if you don't write this bracket, also this is not a problem, right?
Okay.
Basically the same thing, right? So what is the limit of this sequence AN? What is the limit of? What is the limit of this sequence AN? First tell me.
100.
100, right? What is the limit of this sequence BN?
BN is 0.
0, right? So now what you basically need to do, you need to just substitute this thing over here, right? So this is basically what? Log 10 100 plus n is 100.
100 by 10.
10
minus 7 into 0.
Right?
And this is equal to 2.
2 plus 10.
2 plus 10.
So this is basically 2, right?
Yes, sir.
And this is 10.
12.
Right? This is 0.
Yes, sir.
10 is 2. Okay, log 10 is 2, not 10. Okay.
Yeah,
Yes,
so
sir.
this is basically what? 10. I guess you have made mistake here, like 10
Yeah,
square.
log 100, I take it as 2. I mean 10.
Yeah.
Expression I took it as 10. 10 plus 10, 20.
Yeah, so see, that is the problem. Like you have all did everything. Now, because of this mistake, basically you lose all the marks. Yeah.
Thank you, sir.
Yeah.
Sir, I have a doubt. Like, if in quiz we get tan x by x, the limit, if we have to find the limit of that sequence, then what should you consider?
So you are saying limit Sorry, limit n tends to infinity?
Yeah, yes, sir. Tan n by n.
Okay, so the initial thing, whatever we have discussed. Okay. See,
Yes,
one thing, again, like I have to check it properly. Like I have to take bunch of things, then only I can say about this question. But one thing I can assure you that this sequence is certainly it's divergent. This certainly it can't be convergent. Okay. That certainly I can tell you. Okay.
Yeah, so in such case, the limit does not exist.
Yeah. Because certainly this is sort of uh, in some sense, this is actually what? In some sense, tan what? Tan n is oscillating, right? Correct
Yes,
or
sir.
not? Yeah.
Yes, sir.
So that's why actually this function can't be this sequence, whatever this tan n by n when n tends to infinity is most likely it will diverge. Okay, but to prove this, okay, I have to think. Okay, how I can prove it rigorously.
Sir, I have a question. Can we write tan n as sin n by cos n? And can we have sin n by n multiplied by 1 by cos n and have limits of these two products? Will that work
Just
out?
just a minute. Tell me.
Can we have tan n as sin n by cos n
Sin n
by cos n
cos n.
and then multiplied by 1 by n, and we can have
Hmm.
two separate limits, sin n by n and 1 by cos n.
Hmm. N
And 1
times
by cos n.
cos n. Yeah. Then what you do now?
Then two separate limits we can take.
That is the problem. Now you can do that. Okay. So when actually see limit, the biggest problem is limit n tends to infinity, an times bn. This you can apply when you know that this limit exists, this limit exists. Okay. Then only you can apply this. But the problem is this limit doesn't exist. Okay. So limit n tends to infinity, 1 by cos n doesn't exist. Okay, so again the same argument. This is actually a oscillating function. Okay, so otherwise you can easily uh, take the individual limit. So this n tends to infinity bn. Okay, so this you can apply only when this limit exists. Okay, limit n tends to limit n tends to infinity an exists and this exists. Okay, so the here the problem is you know that this limit exists, right? That you know this is 0, right?
Okay,
But
sir.
you don't know whether this limit exists or not. This limit actually doesn't exist. Okay, so you can't write this as limit of this times limit of this. That you can't write. Okay, so
Okay, sir.
that is the rule of limit here. Again, like for the proof, I have to think, but I can guarantee you that this limit uh, doesn't exist. Okay, any other question?
Thank you, sir.
Yes, sir.
Hello.
Sir, I have a doubt in a question from mock 5. So third question, we have been given a sequence an is equals to an minus 1 plus an minus 2 whole divided by 2 for all n is greater than or equals to 3 and a1 is equal to 0 and a2 is equal to 1. Then how
Have
can
you
we
have
find its limit?
Yeah, this solution is given, right?
Sir, I can't understand.
Yeah,
Can you please?
which part you so my question is which part in the solution is not clear to you? Because this is a big question, right? So you have to make sure.
Yes, sir.
Yeah. Yeah, so tell me which part is not clear to you. Then only I can probably start solving this question.
Okay, sir.
Hmm.
So how can we find it like uh,
Yeah, tell me, which part of that question is not clear to me? Okay, let me open that solution.
So in the meantime, I just have a question. I mean, when you are done with week 7 and 8, I mean, the every doubt, I have a question. I hope you remember that I did ask you in the beginning. It's not from week 7, 8 or anything, but it's a question that is bothering me because I cannot find the value of E in a parabola actually. So if you like allow me after everything is done, so I'm just gonna ask you the question. Focus.
Yeah. Well, this is the solution. Yeah, so tell me, like, this is again, like, if to solve this question again, like, this will take maybe a lot of time me to completely explain this. Okay, so my doubt is, what is your doubt in this solution? Okay, that is what my doubt. My question is, which part of the solution?
Actually, I do have the
Yes, sir.
same question. Doubt.
So option 4 is correct is written. After that, now summation of AI is equals to. There I cannot understand. Yes, sir. That second step.
This one, right?
Yes, sir.
Just a minute. What is my pen? Okay, this is in white. Okay. Okay, so this top part is not clear.
Yes, sir. This part and the next part also.
Sir, can you explain this whole question? Like,
So
I
this
do have
they
the
have,
question.
just a minute. They have proved it, right? So here they have proved this statement. Okay, this statement what you are saying. Here they have proved it, right?
Sir, the statement which is written after that, like next. Yeah,
This
A3
one.
plus F2
This one.
plus. Yes, sir. Yes.
This one. This one. Which one you are saying?
Yes, sir.
So what is this thing? Summation of I3 to n ai. What is this thing? What is this thing? What do
Yes,
you
it's
mean by
summation
this?
of AI.
So you are basically adding A3 to AN, right?
Yes, sir.
So that is what it's written here. Correct or not?
Okay. Yes, sir. It's
So
correct.
what is this one? What is this part? You are adding AI from 2 to n minus 2, right?
Yes,
That
sir.
is written here, right?
Yes.
So it's clear, right? So from how we are getting this step?
Yes, sir. It's now clear.
Yeah.
Okay, sir. Thank you.
Yeah, thanks. Yeah.
Sir, I have a doubt in activity 8.1, fifth question.
8.1.
Fifth and seventh question, where it involves tan inverse in seventh question. Fifth question is about intervals.
8.1, question number?
5.
Question number 5, right?
Yeah.
So basically in question number 5, it's saying that there exists a continuous function from 1 5 to 1 7, right?
Yeah, such that f of 3 is equal to pi.
Yeah. just let me share that other screen. So yeah, so basically what you want a continuous function from where to where? 1 5
5 and 1 7.
right?
Yeah, such that f of 3 is equal to pi.
Okay, is there any other condition? Okay, f of 3 is equal to pi, right?
Yeah.
So now you take this function f of x equal to pi.
Okay.
For all x in this point. This is a constant function.
Yes.
This is continuous.
Yes.
F of 3 is equal to pi. F of 3 is equal to pi or not in here?
Yes, sir. Correct.
So then there exists. So option 1 is correct, right?
Okay. Okay. Okay.
But again, like not some of okay. So for example, let me I am not going to discuss all those options. Let me take the second option. Let's say you want a continuous function from where to where. In that
1
case,
1 comma 10.
Hmm.
Closed interval 1 comma 10 to closed interval 2 comma 8.
2 comma 8, right?
Yeah. Such that f of 1 is equal to 3 and f of 10 is equal to 5.
5, right? So you want a continuous function, right? Whatever it is.
Okay.
So that f of 1 equal to 3, right? That means 1, the value is 3, right? So this is 1 comma 3, correct?
Yes.
And 10, the value is what? 5, right?
Yes.
5, sorry, this is 10, 5, correct?
Yeah.
Now you draw a line segment joining this. This is a continuous function.
Yes.
Right.
Yeah.
And as you can see, this image basically it will be in between 3 to 5, right?
Yes.
Because this is 3 and this thing is 5. So 3 comma 5 is certainly it's inside this side, right?
Inside 2 comma 8. Yeah.
Yes. Yeah.
Okay. Okay. Okay.
Okay. Let me discuss. Is there any?
Sir, the next seventh sum also you have the tan inverse of define a function f as follows: f of x is equal to tan inverse of 2x. So will they be giving us any formula for us to know this tan inverse? How to solve this, sir?
So there is a formula, like we have discussed one formula. Sir has given some formula, right? Tan x by x is basically limit x tends to 0. What is tan x by x? Hello.
Limit x tending to 0, tan x by x is
It's 1, right?
Hmm.
So it's the same thing for tan inverse is also, no?
Yeah.
Like tan inverse x by x is also 1.
So tan inverse x by x is also 1, right?
okay. Okay. So then we can the reciprocate and okay.
Correct. Correct. It is basically the same thing. You just multiply by 2 and divided by 2.
By 2.
Then basically you will get half. Okay. In that case.
Okay. Okay.
Graded assignment question number 7.
Sorry?
Graded assignment 7, question number 9.
Which one?
Graded assignment 7, question number 9.
Week 7, right?
Yes, sir.
Again, like I'll ask the same question. Have you checked the solution?
Yes, sir.
Sir.
Yeah, you check the solution. This is I remember this is a very long thing. If you have any doubt from the solution, then only I will discuss. Okay. A specific doubt from the solution itself. Okay.
Okay, sir.
Yeah,
Yes.
revision session is over, sir.
Yes, revision session is over. Yeah. So if
Shall
you
we leave? Small guidance.
Shall I leave?
Yeah, you can leave. Like revision session. Now I'm just taking your doubt. Okay. Yeah.
Sir.
Okay, sir. Thank you.
Yeah. Yes. Hello.
Sir, this type of someone you have already done, sir, but I could not find it. So problem is, let f be differentiable function such that f prime of 3 is 2 and f of f prime of 3 equal to 2, f of 3 equal to -7. If y equal to x plus b denotes the tangent of the function.
If y equal to
ax plus b,
a
linear line formula, denotes the tangent of the function at x equal to 3. Find a plus b. I approached in two ways, sir. One directly that function f prime a into x minus x plus a minus f of a. That is the one function you can put now, sir. So, but I am getting the 2 into x plus 3 minus of -7.
So basically, what you are trying to find? You are trying to find the tangent line at x equal
Values
to
of
3.
a and b.
Yeah, values of b, but okay. So this y equal to get the values of a equal to b, you need to find the tangent line, right?
Yes, sir.
Yeah. So let's say this is your function.
So the tangent is already given, no, sir. F dash f prime of 3 is slope.
Not tangent is given. The slope of the tangent is given.
Yeah, that y equal to ax plus b, that a will be the slope, no, sir.
Yeah, a is the
Still,
slope.
we need to calculate. I mean, if we calculate the tangent equation, it would be 2 into x minus 3 minus 7. So we need to calculate the values. We just cannot say a is 2 and b is 7. I mean minus 7.
So
from b is not -7.
So from here actually you can say that the value of a is 2. Okay, but certainly you can't say about the value of
b is -7 because we have another thing to calculate.
Yeah.
B is not -7.
Minus of f of a, no? Minus of f of a. Minus
okay,
of f of a into +7.
Y equal to -7.
Let me. Okay, please let me allow. So okay, just allow me to compute. Okay, so after that we'll get the. So this point is what? This point is basically 3 minus 7, right? So here we are trying to compute the tangent. Okay, so this is the tangent we are trying to compute, and this we know the slope of this line is 2. So the equation of the line is basically 2. This is 2, right?
2 into x minus 3.
3
minus 7.
Minus 7, right?
Yeah.
This is basically f of a, right? So then you will have 2x minus 6, right?
Yeah, minus 7.
So then you will get 2x minus 13. 13, right? 7 plus 6.
Yes, sir, 13.
Sir, I have
now you have this is a and this is b. So if you add, then certainly you will get minus 8.
Sir, I have a question,
but,
sir.
Sir, but in the t equal to formula, you have to take minus f of a, no, sir?
No. This is f of a.
Plus of -7. It should be minus of -7, no, sir? Formula?
No. This is the formula. Like again, like you don't have to remember any formula here.
Okay.
This is the formula, right?
Yes, sir. I made a mistake, sir. Sorry. Thank you.
Again, like see, the thing is okay. So yeah.
So here, how we got that is y minus f of a equal to like that point.
Okay, so
slope
the
formula.
thing. Yeah. Point. Yeah.
I got it.
You don't have to remember this formula. Okay, this formula is not needed. Okay, so this is completely there is no point of remembering that formula. So you try to remember the slope line formula. Okay, so certainly you know
Correct,
that.
sir.
Yeah.
Thank you, sir. Thank you.
Yeah, thanks.
Bye, sir. Thank you.
Yeah.
Sir, I have a doubt in activity 6.3. Can I ask? It's a log question.
6.3.
Just wanted to know the domain of f, ln x, where fx is
6.3 question number what?
Question number I think 2.
Hmm.
If domain of fx is equal to -3, 1, then domain of f ln x.
So what is your function?
The answer is given. Function is ln x. Fx is equal ln x. Fx domain is given -3, 1.
Okay, question number 1 you are asking then.
Yes, question 1. Fx is -3, 1. Then domain of f ln x. Answer is option 4, but I'm not getting.
Okay, just a minute. Let me read that question. So, okay, please mute yourself. The domain of f of x. Domain of f of x is -3, 1. This is the domain. The domain of then the domain of f of ln x. Domain of
F of ln x.
f of ln x, right? What will be the domain of f of
Yes, yes.
So so you know that f is defined in this interval, right? -3 to 1, correct or not?
Right.
So then f of ln x will be defined if ln of x is basically inside this interval, correct or not?
Right.
Because if certainly if ln x will be something else, maybe ln x is 5, then f of 5 is not defined, right? So ln x, yeah. So that means we want our ln x to be inside 1 and inside this, right?
-3. Correct.
So now you take e, right? If you take e, then this basically e power -3.
-3 and 1. Correct.
Yeah. Clear, right?
Yeah, clear.
Okay, yes. Sayan, you asked some. Yeah, you want to.
Yes, sir. So, sir, it is given in the question. There is a pole which is 15-meter long, and it is at the origin. And from the bottom of the pole, I mean, from the origin, we are like shooting a rocket, and its path is parabolic. And it is reaching its highest point at 15. I mean, its highest, peak point is 15 meters, 15 units from the ground, and it is traveling for 30 meters. Sorry, not 30 meters.
Okay, so just a minute. Okay, it's really difficult for me to remember the question.
Okay, sir. I'll just go one line by one line. So, sir, the pole is 15 meters long.
So my question is it from some activity or something like, so that I can?
No, sir. It's from the September question paper.
Previous year question, I think. That's the previous year.
Okay. So you have a pole. Okay, this is the pole.
Yeah.
This is 15 meters long, right?
Yeah, 15 meters.
This is 15 meters long.
Yeah.
Yeah.
And from the bottom of the pole, we are shooting a rocket.
From the bottom of the pole, you are shooting a rocket. Yeah.
Yeah, and its path is parabolic.
Yes, fine.
The highest point it is reaching is 15 meters from the ground.
Okay, so basically it's reaching 15 meters from the ground. That means this is basically this.
Yeah, yes, sir.
Yeah, so this is basically same. Yeah.
Yeah, they're the same. And sir, the distance it is covering from the origin point, I mean the bottom of the pole, that is origin already.
This is origin.
So, yeah, this is given origin. So, sir, from origin, it is traveling 30 meters.
From origin, it's traveling 30 meter. I didn't get this line.
I mean, sir, the last point of the rocket, I mean, where it is landing in on the ground, from origin, the distance is 30 meters.
So this is 30.
Yeah, that is 30 meters. Yeah. So, sir, from like this rocket part is over now. Now, from the top of the pole, a ball has been thrown.
So from here.
Yes, sir, from the top. Yeah, from the top of the pole. Yeah, from there. So a ball has been thrown, and it is a half parabola, and it is reaching the ground, and it is traveling 20 meters. It is traveling for 20 meters from the top. I mean, from origin actually. Yeah, that point is 20. Okay.
Yeah.
So, sir, they asked for both the equations. So, sir, I calculated both the equations. That is fine. But the thing is, whenever we are calculating any parabolic equation, we have to consider the stretch factor. Not stretch factor, actually. Whenever we are saying like ax square, something like that. So we have to calculate the value of a. So I don't know how to calculate the value of a in this case because nothing is given.
Which actually one? See, this part is pretty easy, right? This one, computing this parabola, equation of this parabola.
That ones are easy, but for this half parabola actually.
So the thing is, for the half parabola, okay. So the thing is, you know that parabola is sort of in what sense, like. So is there anything given like what is the axis of symmetry of this parabola?
Sir, that point is given, na? No, that one is not given, sir. But sir, I mean, sir, that point is like 15. I mean, 0, 15, I think that would be the axis of symmetry. Because the initial point is there.
No, you are saying for this parabola, right? This blue parabola.
No, sir, the red parabola. I mean, the ball has been thrown from the pole. So for the red parabola, that would be the axis of symmetry.
Okay, sir. Correct. Yeah, it's correct. So now it's easy, right? So this is your axis of symmetry, right?
Yeah.
So the parabola is symmetry about the axis of symmetry, right?
Yeah. Yes.
So if this point is 20, 0, then this point should be minus 20, 0, right?
Okay.
So then you are done basically, right?
I mean, sir, the calculation of a value, I'm just asking that. I mean, from vertex we can find, but that a value, how can we find? Because the answer was pretty
No.
clear.
So the thing is, okay. So the thing is, okay. So the problem is, okay. So this parabola you will be of this form. Let's say y equal to 4 something like that, right? 4a x square, right? This parabola.
Blue one, right?
Blue one. Okay.
Sir, the blue one was actually given. I mean, I'm telling you the answer actually. It was given y minus 15 is equals to minus 1 by 15 into x minus 15 whole square.
Minus 1 by 15?
Yeah, into x minus 15 whole square. So, sir, see, I actually put
just
instead of
just
okay.
Just yeah, tell me.
So, sir, when I was solving this question, so, sir, we just cannot put anything in that place of a, right? We have to write like y minus 15 is equals to, since it's an inverted parabola, so it would be minus a into that vertex form of the equation. So that's
see, the
what
thing
I
is,
did.
okay, so don't, okay, so again, like I'll suggest don't, okay, it's up to you. Like, see, the thing is, so this is a quadratic equation, right? The first thing is, this is a quadratic equation. F of x equal to ax square plus bx
plus c.
Right? So one thing is clear that the thing is that which you can write some, let's say, some a times x minus alpha, x minus beta.
X minus beta, yeah, we can
So
write
now
that.
you know that, so you know that what is alpha and what is beta here, right? This is 0, one root is 0,
Yeah.
one root is 30,
30,
right?
yeah, yes.
So you know that this is basically a times x minus 0 times
And
x minus
30.
30. Okay.
Yeah.
So one more thing you know, right? You know this point, right? This point is what? 15 comma?
15, yes, sir. 15 comma 15.
So now you apply 15. So if you apply 15 in the right, you should get 15 in the left, right?
Yes, sir. Yeah,
So
yeah.
from there you can get the value of a. Okay.
Oh, okay. And the same for the half
Yeah.
parabola, right?
Yes. Because see, you know the one root minus 20. Another root is 20. Okay. And this point you know 0 comma 15.
0 comma 15.
So
Yeah.
this will give you the value of.
Okay, sir. Got it. So we need to the root formation of the equation.
It's okay. It's easier for, at least for me. Like if you there are multiple ways of doing this. So if you can do some symmetry. Okay, so if you know the axis of symmetry, I guess there is a formula like y minus a square, something like that.
Yeah, it's the vertex form, I guess.
But
Yes,
again,
yes,
like,
sir, got it.
yeah, so if you know the roots, then actually you don't have to do all these things. You don't have to remember anything. You just simply apply this thing.
Okay, sir. Got it, sir.
Yeah.
Thank you, sir.
Okay, so then I'll stop the session now.
Excuse me, sir.
Yeah, please.
Sir, I have a general doubt. Is it possible to have solutions for the assignments?
Which
For
assignment?
no, like questions in the videos. Is it possible to have solutions for them?
No, I don't understand. Which
The
video?
tutorial video she is talking about.
So you want
Tutorial videos.
tutorial videos?
No, after have assignment questions. Sorry, activity questions. So is
So
it possible to have answers, solutions for them? Like we have only answers, and
no. Activity question, we are not going to provide you the solution for activity question. That is basically it's your job to solve the question, and if you have doubt, you can ask. So yeah, certainly we'll provide.
We keep on doing hit and trial, and we don't know that whether we have solved it.
Yeah, that is how you learn mathematics. It's not mathematics. That is how you learn any subject. You have to try it, and you should learn. Like that's the main idea of learning any subject. It's nothing special about mathematics.
I want to, but after trying, I am not sure whether I have done the question in right form or not.
Yeah, the solution. You know the solution, right? So if you are, so that's why we are having this live session or discourse or whatever.
I'm just trying to make you understand that being a non-science background student.
Yeah, I understand that. See, so the thing is, okay, so like, so there is nothing special. Okay, so as I said, I completely understand. Like you have to do a lot of hard work if you compare with a some.
No, sir, I don't get assurance that whether I have done it correctly or not. It happens that I have solved any question, and when it is discussed in the live session, I come to know that I have done something wrong. Like it was just a luck that I have reached the answer. So I'm not able to build confidence that I'm doing it correctly.
Yeah, that is what I am saying, right? So that is so the thing is we are basically giving you the solution of practice assignment and graded assignment, right? So if basically we'll provide you solution of each and everything, then what basically you are going to do? My first question is this. Okay, then what you will? So basically there are few questions you should try and you should try to get the solution by your own, and in case you are not getting, there are multiple ways of of getting the solution. That is basically we are conducting this. So as you said, how you can verify, like that's why we are having this live session and as well as this discourse. Like there you can post your solution, and certainly one can verify whether it's correct, whether whatever you are doing is correct or not. Okay, so again, like as I said, see, the thing is, if you are from non-science background, then definitely you have to do more hard work. Okay, that certainly I am not saying that it's very easy for you. Okay, for a science background, if he's putting some time, then for non-science background you have to do more effort. Okay, so I'm not denying that. Okay, but again, like just by giving you the solution, it's not going to help you much. Okay, because whatever, see, it doesn't matter whether it's a science background, they have also gave effort, and after that only they are in this condition. You certainly you can't skip that part. Okay, you have to also put that effort, then only you can come to their position. Okay.
So I just have one last question.
Hmm.
Sir, whenever we are tracing tracing a piecewise function for the limits, I mean from both the sides. So it's like I call it tracing because it's pretty easy for me to understand. So yeah. So if we have a function like three functions piecewise and we are tracing one function from the left, and let's say it is not taking a value at certain point, we are actually trying to calculate the limit. Let's say x equals to 2 at that point. And we have a parabola, and the parabola, the right hand side of the parabola is not taking the value of anything, like let's say 8 or 10 or 11.
Just a minute. Suppose you have a parabola.
Yeah. With imaginary roots and having axis of symmetry, so on the positive side, sir.
Suppose you have this parabola.
Yeah. Just like this. And sir, let's say we have another like two piecewise functions. One straight line could be there or anything. So at x equals to 2, let's say I want to take a value. I mean, I want to calculate the limit.
This is x equal to 2. This is a parabola, right?
Yes, sir. But if you take x equals 2, then I mean it's different. But yeah, but still it does count. So whenever
this parabola is continuous, right? Everywhere.
Yeah. It is continuous. Yeah, it is continuous. But so what I was trying to say, at the end point, let's say we have bounded the parabola, and let's say any end points, like let's say on the right side, the end point, the right end point where the parabola you have ended, let's say it's taking the value to
you are taking some part of the parabola. You are not
Yes, sir,
taking
yes,
the
sir.
so
Yes, sir,
this
yes.
let's say this is the part. Okay. Let's say this is a point, let's say x equal to 1, let's say.
Okay.
And
Yeah.
this is, let's say, x equal to 3.
Yeah. So sir, now and from x equals to 3, there like another half parabola is actually going up, and like whenever, like if I want to calculate actually, and yeah, that parabola is not taking the, I mean not
Suppose you have another parabola like this.
Yes, sir, just like this. So sir, whenever I'm trying to calculate, I mean, like not try, I mean, whenever I'm approaching this, or whenever I will approach this kind of question, so sir, at from left hand limit and right hand limit. So in that case, so sir, that point, I mean, that junction point, or like if it is touching each other, so it's fine. But what if it's not touching? I mean, if both the parabolas are like open circle, I mean, not taking the value at that point. So sir, if we trace the value from both
the
the
thing,
ends,
okay, so the thing is
gonna
depend, like, see, if this is not the value, then see, it's pretty easy to calculate the left hand limit and the right hand limit. Okay.
Yeah.
So because if you are coming here, then basically it's going towards this point, right? The value of the function is going towards this point. And similarly, same thing will happen in this direction also. Okay. Now the question is whether the f of 3 is basically this point or not. Okay, that is the question. Okay. If f of 3 is not that point, then the function is certainly not continuous. Okay. But as you can see, the limit of this function in both the sides are same, right? So
Yes,
limit exists. Okay. Limit certainly exists. Okay. Because you are basically coming to the same point. Okay. The only thing matters whether the value of the function at 3 is this point or not. If the value is something like this, let's say the value of the function is at this point is this one. Okay. In that case, this function is not continuous. Okay. And suppose also the value of the function is that point. Okay, that point. That means the function is continuous. Correct or not?
Yes, yes, it is.
Now you try to check the differentiability. So the thing is, when you are coming from this direction, left hand side, right? If you try to draw the tangent line, then basically you will get a tangent line like this, right?
Yeah, yes, sir. Yes, sir.
So this slope of this line is precisely your left hand
derivative.
Right. And when you are coming from the right hand side, so again, if you see, actually you will get a tangent line like this, right?
Yes, sir.
And the slope of this line is basically right hand derivative.
Right hand derivative.
And okay, so certainly the slope of these two lines are different.
Yeah. One is positive slope and one is negative slope.
So in that case, this function can't be differentiable at that point.
Okay. But I mean, I had that confusion over there. I mean, that value point of.
But again, like if you have something like this, then most likely it will be differentiable. Like let's say, suppose you have okay, so this is badly drawn. So okay, let me take. You are saying actually initially, I guess you are suggesting this is opening upward. Then you need, suppose if you consider another like this, right?
Yes, sir.
So in this case, actually, this function will be differentiable. Okay, because it doesn't matter actually how you are. So if this is now it's more or less like a sine function, right?
Yeah, like a smooth curve sine function. Yeah.
So in this case, actually, if you join from this direction also, whatever you will get is the same thing you will get from the right hand side, the left hand derivative, both will see. Okay, in both the direction you will get a unique tangent.
Yes, sir.
But this is not correct if you draw a graph like this. In this case, you are getting two different tangents. Clear?
Okay, sir. Yes, sir. Got it, sir.
Okay, fine. Okay, then I'll stop now.
Okay. Thank you, sir.
Yeah. Thanks. Okay, all the best for your exam. Yeah.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you very much.
Absolutely.
Sorry, sir. Thank you, sir.
Yeah, thanks.
I'm very sorry. I forgot to mute when I was talking with the man.
Yeah. So again, it's okay. So you are doing so.
Very sorry.
No problem. But okay, so you should. It will be better if you'll be careful.
No, I didn't realize she just came into the room and she's a student of MSc.
Yeah, so that is the point. So
the
thing is okay. So see, it's sometimes no problem. So sometimes it's actually for us sometimes it's difficult to tell each and every. Maybe you are doing it for the first time. Okay, I understand.
No, I'm a senior citizen.
Okay, so I understand. Like guys, So the thing is, sometimes it's really difficult. Like
the younger generation, they are not aware of this course. So she just came in and I was apprising her of the course. I was telling her, why don't you also
So in generally, actually, what I do most of the time, I go and mute that person. Okay.
Yes.
But okay,
I'm sorry, I forgot to mute it.
Yeah. Okay, no, not an issue. Okay.
Okay, thank you, sir.
Thanks.
Have a good day.
Yeah.